Hello, hello, my friends. I'll be the last one to join the party. Welcome to the 2023 ICPC Mid-Atlantic USA Regional Contests. My name is Lydia Perovsky, and I will be your host for today. I hope that you already had a chance to check out my incredible colleagues that are currently running 2 and other live broadcasts of ICPC regional contests in North America, being Second Thread, who takes excellent care of Pacific Northwest contest. And today we are also joined by Geothermal, who streams ICPC live broadcast from South. So we'll be following these 2 contests also very closely, and I hope to be able to join on one of the calls later today. But for now, we are here together for the Mid-Atlantic region. Absolutely let me know if you'll notice something interesting going on in the broadcast. I'll be monitoring comments here and there. But also absolutely feel free to send my best wishes and regards to, once again, our wonderful co-hosts on other live streams. I'm very much looking forward to this being treated as a single experience that we run with 3 commentators and at the same contest at the same time. Only part of the problems are shared today, so absolutely keep a close eye on the way the contest progresses. You should be able to follow the contest itself on official contest website. So if you only have a few minutes to join us for this broadcast, then just go and check the official scoreboard more often. I'm sure this will give you plenty of time to figure out your favorites and make sure that everything is just fine. Well, also another excellent thing that we have today is you are able to participate in a contest with the same problems online. There is an open contest with the same problems, the same tests, same everything that anyone can join. And so I very much invite you to try your hand at this problem specifically, because as we noticed today, just through the first few minutes of the broadcast, because we are now 22 minutes into the contest, there are a lot of pretty doable problems, specifically in Division 2, obviously, but not just. And in Mid-Atlantic contest today here, we also see a lot of problems solved already, even though we have barely started. So please come join the open contest, try yourself against these problems. I'm sure you will have an exciting day and you'll be able to learn something new, even if you just spend half an hour of your time figuring out how these problems work. Well, this is all fun and games. Let's take a few seconds to actually monitor the scoreboard, and I'll be happy to get you up to date with what's going on in the contest today. So, shall we begin? Okie dokie. Yay, here I am. Well, most of the contest will span today in this specific view. At the very bottom left, you can see my clock, which signifies how many exactly moments or even seconds passed from the very beginning of the contest. The contest itself runs for 5 hours. Through the first 4 hours, we'll get full information flow. Nothing will be secret from us. But for the last hour, we'll have what we call freeze time, where we'll be able to see if we won't be able to see if contestants actually solved anything. They will receive full information about their about the results of their submissions, but well, unfortunately not us. And this will give us a lot of opportunities to, try to figure out how build hypotheses about what kind of problems were actually solved and which one were not. So yeah, this is going to be an exciting last hour, but for the first 4 hours, we'll get full information. Nothing will be hidden from us. This is going to be a lot of fun, I believe. To the bottom of me, you see what we call a scoreboard, so a testing queue. So our contestants are trying to solve these problems as fast as possible. Every time they solved a problem, these problems get sent to an online server, in this case, a Caris server, exactly the same that you can be using to solve these problems yourself. And the server then gives the team a feedback. Was their solution good enough? Did it pass all the tests that were prepared by our incredible judges? Well, exactly that progress you can see in the bottom right corner. Every time we see a submission, we see current team name, current team position, we see team name, we see how many problems has this team solved so far. We see information about the problem that the team submitted into, because our contest has problems from A to L, so quite a lot of them today. Then we get the verdict. When submission is still testing, you can see this pretty tiny yellow progress bar is now for problem C. And as soon as this progress bar reaches the rightmost corner, it either goes red for incorrect submission or green, as we see, for a correct submission. And this is very exciting. I'm very much looking forward to a lot of correct submissions today, a lot of exciting updates. The only thing that you need to do is to hope that as many yellows turn into green as possible. If they turn into green, then hooray, team celebrates. And for example, we can see one of our incredible teams who is now in first place has already solved 5 total problems. So give it up for Vanderbilt University. Look for the backup. 5 problems solved. They just submitted correctly problem H. Well, if we look closer to the scoreboard that is on our left, we'll see that every team is represented by a line in a browser that shows us how many problems have they solved and actually shows us information for every separate problem. So you currently see that a lot of green pluses, which represent solved problems, are on problems C and problem G. But other problem solved are also A and I, and there are so many diverse set of teams that are currently in 50 and above position that actually solved not just C and G, but also A. Here is the current solving statistics for our contest. So problem G has 57 correct solutions. Problem C, 48. Problems A and I go head to head, 22 and 19 successful submissions. Problem H has been just solved by 4 teams so far, but we're very much looking forward to this changing, because even though our teams consist of best and the brightest students ever, they are sometimes prone to looking at the scoreboard, just a little bit too much. They pay close attention. It's very important to be able to identify the easiest problem, to not spend time on the problems that you will, struggle with. But still, it's very important to be able to solve the problems that your team likes, solve the problems that your team identifies as something solvable, easy for you, that will not bring too many incorrect submissions for your team. And this is where, even though, once again, teams are incredibly experienced, each contestant actively trains for this competition, sometimes they're just too interested in just solving the problems that other teams solve instead of looking for their own. It's a very fun detail and nuance, and today we will also be able to actually observe that, because some of the problems are shared between contests, and it's very nice to finally be able to have this situation where, even though our teams are solving the same subset of problems, they do not see each other in the scoreboard. So for example, if there is a problem shared by Pacific Northwest and say South contests, teams do not see the scoreboard of other contests. They only see the scoreboard of the contest they participate in. And so the same problem can look very easy for once and can look very difficult for others. I'm very much looking forward to this kind of development. We'll have a lot of fun with that. I'm absolutely sure of it. But so far, every team that solved problem G will just probably go ahead and start solving problem C, and then A and I in whatever order there are. Another exciting thing that this statistic shows us is that there are barely any incorrect submissions. Incorrect submissions are represented by red. And here today, we only have one team still working on problem A, two teams still working on problem C, and three teams still working on problem G. How fun is that? This is an incredibly overwhelming positive result of their problem solving. It's absolutely not like that in every single problem. It's very often that we see some of the problems be so complicated and have so many weird corner cases that teams will actually struggle, and we often see as many as probably half the teams actually be stuck on a specific problem, as in have submissions on that problem, but for a very long period of time to not have an actual correct solution. So I'm very excited for teams today. They seem to be doing great, and they seem to have a lot of problems to solve. So what else can we wish for our wonderful contestants? For ease of understanding, I just added each problem a specific color. So now problem A will be represented by red, problem B by green, problem C by yellow, etc. It will help you to see easier the problems that correspond to a specific problem in a contest and a testing queue. But now I'm very hyped for the submission from University of Illinois at Urbana-Champaign for problem J. They're currently in the second place, but getting an extra problem will absolutely bring them higher in. It's a very curious moment in time in the contest to actually introduce you to the concept of first to solve. So first, we just received first solution on problem J by, as already said, University of Illinois at Urbana-Champaign. And currently, they're in a first place with 6 problems solved, which is exciting. And I think it's a great moment. They are very lucky to receive this first solution. Every first solution, oops, apologies, I'll go get some water. Each first to solve will be marked with this very pretty star that we have right on their queue line. So the star represents a wonderful tradition of ICPC World Finalists who over the years were doing the balloon delivery. For every solved problem, team gets a balloon, and for the teams that are actually solved this problems first, so if no other team solved problem J in this case in the contest before, this is very fun to get this star assigned balloon. Even though not always this dice, or in today's contest, we do not always have dedicated balloon colors, and we do not make sure that every first to solve gets their own specifically star-shaped balloon. We are still very happy to have a callback to that in our visual interface for live broadcast. So I hope that you enjoy it as much as I do. Okie dokie. I'll be back with you in a few seconds with updates of our contests. So stay tuned. We'll be right back. Hey, and I'm back with just a little more water to be able to talk through the upcoming hours. And in a second, I would like to introduce you to the concept of our top of the scoreboard. Let's take a moment together to look at the very leaders of our leaderboard. So in the first place, we currently have Team Ipatsu from University of Illinois at Urbana-Champaign. They, as we've already discussed, were just first to solve problem J, but also they have this very pretty star in the leaderboard for problems A and H. It seems like in my leaderboard they're looking at this, working on these, pink colored problems, but these colors students do not see, so we have all the information only locally for us viewers and to make this broadcast a little easier to understand. They have a total penalty of 93 minutes, and the penalty time is very easy to calculate. So currently, Team Ipatsu solved 6 problems, and for each of these problems, we just sum the time elapsed from the very beginning of the contest to the moment this solution was submitted. So if you go to official scoreboard page of this contest that I will also show you in a second. Absolutely visit this page. This is the most convenient way to follow the scoreboard regardless of specific team that I'm currently looking at. So save this link in your browsers and visit mcpc23.caddis.com/contests/mcpc23. Then you'll be able to see the scoreboard for yourself. So you'll be able to see how many minutes Team Ipatsu actually spent on solving each problem. And you'll be very impressed by this number. So they solved their first problem 2 minutes into the contest. So for problem A, they have just 2-minute penalty time. Then on the 6th minute of the contest, they solved problem C. And surprisingly, this was not the fastest solution for problem C. Fastest solution for problem C went to Team Orange Blue from University of Chicago, and they solved problem C in 3 minutes. How impressive is that? Well, going back to Team Ipatsu, they then solved problem H in 14 minutes, problem I in 17, problem G in 23, and problem J in 31 minutes from the beginning of the contest. Which means that their total penalty time is 2 plus 6 plus 23 plus 14 plus 17 and plus 31. This time exactly is one of the core tiebreakers in case multiple teams have the same problem solved. If you look at the teams currently positioned between 1 and 8 in our leaderboard, you will be able to see that all of them actually solved exactly 5 problems, but they still have a little difference in their performance that allows us to appropriately score them and align them in the scoreboard, not all sharing the same place. And so the next tiebreaker after the number of problems solved is the penalty time. But not penalty time is absolutely equal. If we look at another team from University of Illinois at Urbana-Champaign that's called Unbangable, they are currently in 6th place. You'll be able to see that their penalty time is significantly higher, and it's more than just the sum of times of solution for every problem. This is because for problem H, instead of just a clear green plus in my leaderboard, they have +1. And +1 means that before having a correct solution on their problems, they actually unfortunately submitted an incorrect submission, which means that for each incorrect submission, our teams will get 20 penalty minutes extra. So every time we see a red point in the scoreboard, or as we currently see University of Arkansas, UAF, for just submitted problem A, but unfortunately they received an incorrect submission. They submitted code that is just a little not right. Well, they get 20 penalty minutes if they are able to actually submit a correct solution on this problem. There are no penalty time accounted for problems that are not solved. So our team still will continue working on each of them. Specifically for problem A, I'm pretty sure that they will actually figure that out. So, well, one incorrect submission is not great, but absolutely nothing critical, nothing to be worried too much about. Let's give another shout out for the team Look for the Backup. They were leading for quite a few minutes in the contest. Look for the Backup is a team from Vanderbilt University, and I would like to highlight them as currently first to solve problem G, which also took them just 3 minutes. And the remaining problem that is surprisingly solved by not a team somewhere in the top as a first to solve, team UKY Blue from University of Kentucky solved a problem I that we do not see an appropriate star on the first page. They solved problem I in just 7 minutes. So within first 10 minutes of the contest, we actually had so many first to solve. We had 5 problems solved, and then another one followed at minute 31. But as I've already described, our contestants are keeping a very close eye at the scoreboard, which means that as soon as this initial sprint of new problems is behind, contestants will most likely continue to work on the problems that were already solved by at least some other team, instead of trying to work with another problems. We see there are a few incorrect submissions on problem B, on problem L, and as we go down through the scoreboard, we'll see less and less variety in this. We'll see that more and more teams are just finishing this 4 main problems of the contest at this point, G, C, A, and I, instead of doing something absolutely new and going out there and trying to solve other problems in the contest, which is, once again, as I've already said, absolutely natural, absolutely nothing to be frowned upon. At this point, we have 72 teams who have solved at least one problem. We'll come back to this checkpoint in 15 minutes as we'll hit a 1 hour mark of our contest. Another fun observation would be, so this 4 first problems of our contest, so problems A, C, G, and I very much love calling them the early game or the debut problems, depending on if you're an esports person or a chess person. The general concept being these problems that leaders solve within the first hour, well, these problems will be the ones that our teams are actually actively working on, even if the teams are not from the very top of the scoreboard. So if you're a team from the second half, you will be looking at these 4 problems for a good chunk of the contest, which is, as I already said, a great strategy to solve as many problems as possible. These are the problems that contest leaders confirm that are easy, solvable, doable in a few minutes. Well, obviously, contest leaders are very strong teams. They train a lot, they know a lot of algorithms, they know a lot of data structures, but well, if they solve a problem in 3 minutes, you should be able to get it in 300 minutes, right? So this is currently the way our teams work towards. On the other hand, if you want to be one of the top teams, you have to think using a strategy that's called a +1 strategy. To get into a top 10 range on any competition, you usually have to solve all problems from early game and mid game and one more. Your competitors will obviously try to solve as many problems as possible as well, but this is the exact chance to be able to lead them not by the penalty time, but instead by number of problems solved. This is just an approximation. Obviously, every contest is unique, but as we have quite a significant statistics on how the contest goes, this is what our contestants look forward to. This is what they try to focus on. Excellent. Well, just in case you missed, there is an open contest running, so make sure to visit the open contest as well. This is a great opportunity to check your strength against the problems that were prepared by our judges. As I already said, well, if our contestants can solve it in a few minutes, well, maybe you should be able to solve it in an hour. To do so, you just need to visit this webpage. I would be happy to show it to you in a second. This is also a link on Caddis. So just one platform to use them all, which I find very nice and convenient. What an excellent effort by Caddis team to support contests in North America. So if you visit open.caddis.com/contests/mcpc23open, you'll be able to solve the same problems that are currently presented to our contestants in real time, and check if you figured them out exactly correct. Let's visit this webpage together. To do so, you will need to log in on Caddis, which is very easy to do through one of the social accounts that they authorize, and then register for a contest. You'll be able to see the same problems of the round and hopefully use one of the supposed programming languages, available programming languages on the website. Contestants are just a little bit limited with the number of languages that they are allowed to use. Well, programming languages that are allowed on ICPC competitions are C++, Python, Java, and Kotlin. Most of the submissions, well, I'd say overwhelming part of the submissions are still submitted in C++. This is a very useful detail in general, and I think that many contestants try to make sure that C++ is their main language of choice and is something that they're very familiar with. But obviously this has some disadvantages. So for example, in the problems that require using large numbers or big integers, our contestants are very often switched to one of the languages that support that out of the box, being either Java, Kotlin, or Python. But it comes with their own disadvantages. Obviously, even if you use Python and you use big integers in Python, it is going to be significantly slower than whatever code you're actually able to write with C++. So this is a trade-off that contestants need to take into account to be able to successfully perform in a programming competition. In the meantime, we have more and more submissions on the same 4 problems, A, C, G, and I, and we'll continue seeing them throughout the contest, I believe. Let's together root for the few following criteria that we call the criteria of ideal contest. So first of all, in an ideal contest, there is no team that solved all problems within the 5-hour suggested time frame of the contest. This may look a little suspicious at this point when we see already 6 problems solved within the first hour and we still have 9 minutes to go. But in fact, this contest so far looks very nice. I see that there are no easy submissions within last half hour. There are no new open problems. Well, then as soon as we went through this initial surge of excellent submissions and solutions, we may see significantly longer solve times for the next problem. So teams might just very well not be able to solve them all within 5 hours. The second criteria would be every problem is still solved within a contest. I say hi to Kat. Hello. Kat will help me commentate throughout this contest. Well, then we still want every problem to be solved by at least one team. How can that work together with the idea of no team actually solved all problems? Oh, well, it's very easy. There should be a diversity among the problems solved by our contestants. So we're very much looking forward to that. And then we also want every team to solve at least one problem. Because what kind of fun is that if not everyone solved at least something? Our judges absolutely worked hard to make sure that there are a lot of reasonably difficult problems that will be fun to solve for our contestants. And I'm looking forward to seeing that come true. Well, see you very soon, and I'll be back with more information about our contestants and some problem discussion. again, and we have some excellent updates to the scoreboard. We have our first successful submission to problem D. You can see that this submission was surprisingly not from the leading team Ipatsu, but instead from team Orange Blue from University of Chicago, which brings them up to two first to solve of this contest. The first to solve problem C and problem D. They also have a very ambitious attempt on problem B. So if you're one of the U Chicago alums, definitely root for this incredible team. I'm sure they have a lot of great opportunities. At the same time, they are surprisingly not the best team of University of Chicago, because in fourth place we see team called Jack Attack. Well, these apparently, like they're Incredibles, that currently solved 5 problems, so as many as Orange Blue, but did that with significantly better penalty time, just 68 minutes instead of 95 for Orange Blue. Well, we'll see how this competition develops, but we also should keep a close eye on other universities that have significant representation in top 10, which means that teams compete with each other at this point, not just with teams from other universities, but with each other for this incredible slot at North America Championship. So currently, our significant university leader is University of Illinois at Urbana-Champaign. They obviously have the currently leading team Ipatsu, and as we pass the 1 hour mark, they will keep this honorable position of being the best at this point. But also team in third position, team Unbingeable, with 6 problems solved currently, so they're very close to our leaders. Also representing University of Illinois at Urbana-Champaign, as well as team called Ape Pack with 5 problems solved and 89 minutes penalty time, together with team UIUCE. Do you see the joke here? In 9th position, as well as a few more teams in top 20. Excellent performance by University of Illinois at Urbana-Champaign. We'll be looking forward to see how this competition develops. Once again, we're looking at the top teams, and top teams from this contest will advance to North America Championship. That will take place later this year. If you would like to learn more about North America Championship, you can just visit our official website, that is na.icpc.global. Here it is on your screens in just a split second from now. The website has all the necessary information about North America Championship, as well as details, dates, and obviously announcement of the fact that, again, North America Championship will be held together with North America Programming Camp, which is an exciting opportunity for our contestants to improve their skills and also learn together with the best and the brightest from every regional contest in North America. Today, we have 5 regional contests at the same time. 3 of them combined together are the south of North America ICPC, and then we also have Pacific Northwest, and this broadcast is dedicated to, obviously, Mid-Central. Well, I think it's about time that we actually try and take a look at the problems, don't you think so? Here is one of the problems of today's contest. For whatever reason, I figured that we'll start reading with problem G. Problem G, as you saw, was one of the more popular ones. Oh, and we actually have updates in a very top of our leaderboard. We have a new team in 4th position. So Orange Blue solved their 6 problems with problem H and are currently now in 4th position, which is a great piece of performance. Obviously, as I've already said, they should be very happy for themselves with this submission on 58 minutes into the contest, as well as the reason why they finally are up in 4th place is because 68 minutes into the contest they solved problem H. And problem H, we know, has been solvable for quite a while at this point. A lot of teams submitted it. It was first solved 14 minutes into the contest, so they knew that they had to do this, and currently they will either solve problem B, that they already have intent on, or work on problem J, which seems, well, complicated, but definitely doable specifically for them. But at this point, we'll start with one of the easier problems of the contest that was first solved just 3 minutes into. So we should be able to discuss it pretty nicely. So let's look how it goes. Usually, the problem statement is split into separate parts. So our contestants are very familiar with that structure. First of all, we have the appropriate letter. So this is problem G. All contestants know that this is specifically the letter that it will be represented by in the scoreboard and in contest system interface. So Eddie is overseeing construction of some new slot machines. Oof. His slot machines consist of 3 wheels, each of which can show one of several different signs, digits, specifically in this case. When activated, each wheel shows a random digit. The goal is for all wheels to be able to show the digit 7, so that we receive a 777. A slot machine is good if each wheel is capable of showing the digit 7, and bad otherwise. For a given slot machine, determine if it's good or bad. And then as we move forward through the problem statement, we'll see the section that is called input. This is a very strict format in which, in which each contestant and each solution will be able to read the data. The reason that I would like to stop at this moment discussion of problem G and give at least a few seconds of attention to the leaderboard is because currently in first place, Team Ipatsu, they actually solved their 7th problem. So they're currently solo in the 7 problem solved group of teams. They finished problem E, which is also a first to solve. This is why the team went up in the testing queue right beneath me. So it took them 70 minutes to solve 7 problems, but this is very much not the pace that a team can keep throughout the contest. As you can see, each next solved problem takes them a little longer because the problems are more and more complicated. But currently they're first to solve problem E. They did not go look at problem B. They still have these 2 extra incorrect submissions on problem L. So yeah, this will cut them a lot of work in the future, but also as their competitors currently see that, they now know that probably they should dedicate problem E just a little bit of their time. Well, this is a very exciting beginning of the contest. We are just a little over 70 minutes in, and it looks fascinating with already 7 problems open. Well, then we should speed up our problem reading part. Haha. Okay, let's go. Okay. Problem 777. So the first line contains a single integer, n, which is the number of different digits on each wheel. Each wheel has the same number of digits, which is very convenient. Each of the next 3 lines contains n distinct digits in the range of from 0 to 9, which is very convenient once again. Available digits on each of 3 wheels. And we need to make sure that the slot machine is good. If so, output 777, otherwise will output 0. Once again, output very strictly specifies the format in which contestant solution needs to output the answer, and if they will type, for example, instead of 0, if they type no or bad, the solution will not be accepted because there is a very strict format that needs to be maintained specifically for this problem. Okay, I think that the solution is pretty straightforward. So let's look at the sample input 1. It says that we have 2 digits on each of machine's wheels, which is pretty natural. First wheel can output either 0 or 7. Second wheel can output 7 or 3. And third wheel can output 7 or 0. So the problem, when stripped from all the extra statement parts, actually returns us something very easy. You are given number of digits in the following 3 lines, and you need to check if every line contains a 7. If so, output 777. If it's not this way, output 0. Well, I can see why this problem can be solved in 3 minutes from the very beginning of the contest. And I very much invite every one of you to try and solve this problem yourself. Sounds very doable, and I hope it will bring you just this little bit of joy in getting the accepted solution. Currently, 74 teams actually solved this problem nicely, and we have 2 teams who have not yet figured out a corner case here or there, or maybe have another issue in their code. But we are wishing them all the best. I hope that it will take them just a few minutes more to fix this. In the meantime, the team looked for the backup from Vanderbilt University. They're currently in the second place, tried submitting problem L, but unfortunately they received a wrong answer verdict. So, well, it's unfortunate. They will eventually be getting 20 penalty minutes on that problem. It's very likely, and we have more and more incorrect submissions on B's and L's. These problems are very likely, by the looks of it and by the statements of it, to be the next problem solved by our contestants. So very soon we'll be able to see if our guess is correct. If you have any suggestions on which problem specifically do you want to look at, let me know. We'll be happy to try and talk about this problem specifically. But at this point, I will just go from the easier problems to the more complicated ones, just the same way our contestants did just an hour ago. And so the next problem would be problem C. Unfortunately, I will not be able to read this incredible word, Champernowne verification. So we are introduced by the idea of Champernowne word that is obtained by writing down the first k positive integers and concatenating them together. So for example, if we write down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this will be the number. It's just a pretty large number, but every next part of every next Champernowne number can be just generated by writing an extra number at the end, and an extra consecutive integer. So you're given a positive integer n, and you need to identify, oh, and we have submission from a Patso on problem L, but it's also incorrect. Ooh, if I were a judge for problem L, I would have a lot of concerns, and I will be very worried about that. This is fun. Let's see how it works. Ooh, I just received a very interesting invitation, so let's see if we can actually work through that. Second thread from Pacific Northwest Live Broadcast just invited us to join him for a live broadcast in Pierre. So let's see if we can make it work. I'll be back with you in just a few seconds. Oh, absolutely. I can say something, and I'm very happy to be part of that live stream now. And if you say something for my broadcast viewers, I think they should be able to hear you as well.
Yeah, we can do this. Here's a quick test. Make
Let's
sure Zoom's working.
go. Oh, this
Wonderful.
is crazy. Every time I'm surprised when technology works. This is something that never gets old. I'm just very shocked that things work.
That might not say a great thing about the default state, but but that's fine. Yeah, no, we've got this one working, and we have a makeshift scoreboard that we've been able to get to show people based on just like screen sharing the public one. So what regional are you commentating for, Lydia, right now?
It's mid-central, so all the incredible teams from University of Illinois at Urbana-Champaign, University of Chicago, Vanderbilt, they're all here in the top of my leaderboard. Very exciting to follow them.
Home of the one and only Wisconsin as well, I presume.
Yeah, yeah, absolutely. This is exactly the way it goes.
Lydia, are you familiar with the fact that I grew up in Wisconsin,
Correct.
my
I
my home state?
I learned that from an interview that you did at the ICPC World Finals registration couch. This
In
was a very
DACA, right?
exciting moment. Correct.
Yeah, that was fun. It was fun to get to meet some of the teams from there. Great part about World Finals, you get to meet people from all over the place.
Oh, I'm looking
Um,
forward to that. This year is going to be twice as much fun. And we'll need to figure out which teams will go. Well, from this contest, I very much hope that each of us can lead a way for these teams for next September, right? We are currently trying to advance teams to Astana in September 2024. Exciting, exciting times.
when you say twice as much fun, can you explain what in particular you mean by that
Oh,
to the people who are new
absolutely.
here?
So yeah, ICPC World Finals is an event that is supposed to take place every year. Every year we host regional contests that select teams to the championship level events that then select teams to the World Finals. But because of COVID, we are unfortunately running a little late. As you've already noticed, we're currently broadcasting 2023 regional contests. Whereas, well, my calendar just says that it's 2024 already. It's all because of this, scheduling conflicts and us trying to keep up with the clock. And specifically for World Finals, this resulted in us actually having not one, not two, but even three World Finals in 1 year, and two of them that will be held very, very soon will actually be combined, which is
So
hilarious and exciting.
is it the 2020 and 2021 or 2021 and 22 that's happening?
This will be 2022 and 2023. But
Oh,
just
okay.
to make it less confusing, this is not how we call them. We call them 46th Annual International Collegiate Programming Championship World Finals and
And 47th.
47th International
Okay.
Collegiate Championship World Finals. And then it just helps you this little bit figure out how do you identify. So it's always a fun challenge if you know any of the coaches, and I hope coaches are currently watching us as well. When you're trying to identify which year at icpc.global dashboard you need to open, the easiest way for me to go is just to count back from whatever year it is now to 46th and 47th ICPC World Finals.
Yeah, that works, I guess. The tricky part again is that the school year doesn't line up with the calendar year, right? School year starts in like August or whatever instead of January. So even if you have a normal year with no delays, the year that your ICPC finals is in wouldn't correspond with the year you qualified for it in a regional.
Yep.
So it's always a little messy.
And this year, the registration will be able to hear a lot of stories from people who actually graduated university many, many years ago and have been working in the industry or doing their research for a few years already. So I'm sure we'll get some exciting updates from our contestants. And absolutely ask them how were they even keeping up with the whole competitive programming community and how it went. Well, still something very exciting to look forward to. I think it's a little variety, and as I've already said, well, twice the fun.
We have a question here about Div 1 and Div 2. What do they mean from someone who's new to ICPC? So I guess I can take this, Lydia, if you'd like.
Yeah, absolutely. Go ahead.
So my understanding is that Div 2 is more designed for people who are much newer to ICPC and don't really have an interest or an expectation that they'd be able to qualify for the North American Championships. So if you're interested in coding a little bit and you're a little familiar with programming, but you haven't really done much programming contests in the past, your first year in ICPC, for your school's first year, you don't really have a coach or anything like that, then maybe Div 2 will be a little more approachable. Because if you get thrown in the deep end with Div 1, there might only be one or two problems you'd be able to get if you haven't seen stuff like that before. And then Div 1, the main benefit of that is that if you compete in that, you're competing against all the other best teams in your region or in your country, in your continent, even when it gets to North American Championships. And the goal there is qualifying for the next stage. So at this level, you qualify for North American Championships, and then everything from there on is Div 1, right? North American Championships is only Div 1. World Finals is only the very best of Div 1.
Yeah, but also I think it's a lot of fun on how teams identify themselves. Well, obviously, it may seem like solving these easiest problems of today's contest in just 3 minutes. And in mid central, we had give me just a second. One, two, three problems solved in 3 minutes each, and then a few more problems solved very very fast, or probably yeah, and then like probably 7 problems open within the first hour or so. Yeah, within 70 minutes. And it may look overwhelming when you compare yourself, even theoretically, with the teams that can do so many problems this fast, like on average 10 minutes per problem for 7 problems in a row. It's pretty incredible. It may feel intimidating, and you may think that you don't really have a place in Div 1. And what I would be very excited to eventually see and look forward to is the same problems can be interpreted as something that contestant in Div 2 considers being complicated, and surprisingly, contestant in Div 1 in Div 2 can find very easy. So it's a lot more about
Yeah.
you do not have to underestimate yourselves. Just go for it.
The other thing is like, it's not really as linear as you might think, like just difficulty, because there's a second axis to it, which is, in my opinion, originality, right? So there are a lot of problems which are very what people call standard, which means like it's an idea, but it's a common idea that lots of people have seen before. So if you give someone a classic, just like if you give a person who's been doing programming contests for 3 years, you give them a segment tree DP,
Mm-hmm.
right? It's going to be probably not too difficult for someone like geothermal or like me to be able to code out in half an hour. But it's also a very difficult thing that 5 years ago used to be an incredibly difficult problem because people hadn't seen something like that before. And now, if you give someone, a persistent segment tree problem, it's going to be annoying for them to code, but it's not going to be difficult.
Yeah.
But if you're brand new to competitive programming, a persistent segment tree problem is impossible, right? You're not going to invent persistent
Absolutely.
segment trees, especially if you haven't seen segment trees before. You might get really lucky and be super smart and figure out segment trees, but you're not going to be able to invent the persistence, for example. So yeah, there are these things, but at the same time, there can be problems that are very medium to both experts and new people. If the primary goal of the problem is make some observation that's specific to this problem,
Mm-hmm.
if it doesn't require having some tool in your tool case, and it's like, notice that, if you do this algorithm, you can simplify it by doing this unrelated algorithm, which ends up being the same thing. That kind of thing generally those are more popular problems just because like people enjoy them more if it's like very unique and the idea is very specific. But yeah, so I guess the reason I'm saying all of this is that difficulty is not inherently unique, right?
Absolutely.
Even if you're newer to problem solving, you can still surpass people who have been doing it for longer and have more experience.
And even for teams who may seem to be training and practicing the same amount. For example, I currently have 2 teams from University of Urbana-Champaign in first and second place, and they're the only ones who actually solved silent problems at this point. It just happened probably a minute ago, but even them, they have different subset of problems. So they have this 6, let's call it like early game problems as well. 4 of them from the very beginning of the contest, and then 2 more like right around an hour mark. But then one team solves problem E, another team solves problem D, which looks like they read all the problems at this point and they figured this will be more approachable, even though they probably not only study at the same university, but also they were taught by probably the same professors. And so there is no specific difference in their knowledge, but rather in their preference, in their practice, and the way they approach problems and the way they estimate problem difficulty. This is a lot of fun to see. Well, it's also probably not that fun from the team from the second place, which still means that if they close the stop line of the scoreboard, they're absolutely the best, one problem ahead of everyone. But they're from the same school. So, well, NAC slot question can add a lot of attention in here. We'll root for them. I absolutely love myself some, a little Cinderella story, a little subversive expectations in here. So yeah, it's cool to be able to fight against uh, the best team of your university and just lose by 80 penalty minutes time.
Just to be clear about why being from the same school matters so much, only one team from a school can qualify for the next round of ICPC, the North American Championships. Only one team from a school can. So even if you get second place in the regional, which is incredible overall, if the team who beats you happens to also be from your same school, in this case, University of Illinois Champaign-Urbana, then you still don't qualify, right? Because you can only have one team from school
This is
make it.
heartbreaking.
So it's
I
yeah, it's really tough.
I well, I've been following a lot of contests, ICPC contests specifically around the world, and this specific rule as is super region specific. It's not exactly the same all over the world. In some regions, teams are allowed to advance to championship level competition, even if there are multiple teams from the same university. And I always feel like moving this incredible intra-school competition to this early may seem so unfair for the team in the second place. But at the same time, I know that it significantly helps to increase their motivation, their training level. We often see so many excellent teams from the same university if there is that limitation that they cannot go further unless they practice really, really hard. Now it suddenly matters. Suddenly it's not just enough to be good in computer science that you're probably studying for, but you need to actually grind.
It is a tricky thing too, especially for the judges, because the judges have to design a problem set that not only is like interesting and approachable for all of the easy teams, but it can't be dominated by easy problems. If the entire point of this problem set and winning it means you're just able to solve a lot of easy, right? Count how many arrays have 1 7 in it. Um, if the entire contest is like that, then yes, it'll be approachable to easy teams, but you'll wind up with the teams who aren't the most qualified for North American championships being the ones who win just because of these weird penalty um, side effects. So yeah, it's when you're designing a problem set, it's like, all right, how hard do we make it, right? We don't want to burn all of our difficult problems on this when we could use them in World Finals or North American Championships, but we also right need to make sure that we don't have a team win just because of their performance on easy problems.
Oh, tell me a little bit about Pacific Northwest leaderboards. How many teams do you have? And how many teams already solved at least one in each division, obviously?
Yeah, let's take a look here. So we have quite a few teams. In Div 1 and Div 2, I think we have over 70. In Div 1, we have 65 or so teams, it
Ooh.
looks like. But or sorry, I guess we have several hundred, uh, like 140, I think, in both divisions. But in Div 1, we have, yeah, like 65. And we have, I think, like 40 or so in Div 1 at this site. As you may know, Lydia, Pacific Northwest is split across 5 different sites
Mhm.
in different states. We have one team with 7. I guess we have 2 teams with 7 problems. We got UBC and also Stanford Cardinal. UBC has H and Stanford Cardinal has B. That's the one difference in the solved set.
Mhm.
But the thing that's particularly interesting about this is that although currently we're like an hour and a half, 90 minutes into the contest, H was solved by UBC 35 minutes in. That wasn't even their most recent solve.
Uh-huh.
So since solving H, UBC has gotten F and gotten K. Stanford has gotten B, and then no one else has even submitted to H.
Ouch.
H has had one submit 35 minutes in by UBC. That puts them in first place, and they're crushing penalty too. But yeah, it's very interesting. I wonder if it's like some obscure math thing that they've seen before that no one else has. Might
Yeah,
be
this is what I
worth taking a
always
look at.
that is what I always kind of expect from this random submissions from the middle of a scoreboard that are first to solves and they're also like um just here and then top teams do not even approach this. And also sometimes I just know that a particular university is very bad at math. It's very good at math. And so I'm like, will any team probably even consider approaching this problem. This was obviously just a really good at math contestant who went and spent, I don't know, 40 minutes integrating some crazy thing and then figured out a formula that is 1 line long and then implemented that and then hooray, an extra problem right away.
Do you
That's a
happen to
little
have the
story.
problem on call team in your set, Lydia?
Uh, what a
I know,
great question. Let me see.
I know there are a lot of shared problems between these.
Yeah, let me see.
Because if you do, I'd be interested in talking about it. I haven't read it yet.
Uh, no, I don't have one.
You don't
Let
have
me
it.
read you the list of problem names, and we'll see which ones actually match. I'll read them in the order of from A to L. So rampant growth, range editing. Uh, I don't really know how to read this, but chamfer known verification, tournament matchmaking, segment drawing, eccentric excursion, triple sevens, diverse contest, training, balanced tree path, cramming for finals, and matrix fraud.
So you also don't have acceptable seating arrangements.
Nope.
Interesting. Those are the those are the two most interesting looking things from our scoreboard. All right, sorry. What about you have range editing?
I do have range editing, and range editing
It's a tough
actually
one.
was solved.
Oh,
Wasn't
really?
it? Or was it? Give me a second. I think I have plenty of attempts. I have no. I absolutely misguided you. So 8 attempts from teams from all over the leaderboard, but still no successful solution.
All right, let's look at that. That one's we have same thing in Pac
Oh,
Northwest. There are a lot of wrong answers,
nice.
especially from good teams. Like we're not talking like first time here. You just happen
Oh
to
yeah.
misread the bounds and you're trying an n cubed on 10 to the fifth. Like
No,
these
no.
are top tier teams who are getting it wrong. So
Absolutely.
it's
Absolutely
let's
same
take a
for
look.
me. Nice. Okay, let's go. Yeah, I have it on my
I'll
screen.
I'll read the problem for you and then we can talk about it after. Is that all right?
Uh-huh.
All right. So you're editing a list of spreadsheet cells. Initially, all of them are empty, and you can perform two types of operations. The first type is you can select some range of cells in, I guess, a row or a column, maybe,
Mm-hmm.
and change their values to a positive integer of your choice.
Mm-hmm.
Second operation is you can select a continuous range of cells and delete their values and then make them empty.
Okay.
Given the final cell values that you'd like to have in this spreadsheet, calculate the minimum number of editing operations to obtain them. Wait, change their values to a
Mm-hmm.
positive integer. So you have range set basically. So you can like 2D range set and then 2D range clear.
Mm-hmm. Well, 2D or is it either a column or a consecutive range of cells? Oh, it can actually be a rectangle, not just a line.
And I don't know.
Interesting.
They say spreadsheet, right? Spreadsheets are usually
Yeah.
2D,
Yeah.
but it doesn't say 2D anywhere in the problem. So maybe it is just a line. Maybe it's like one row of a spreadsheet, for
Uh-huh.
example.
Uh-huh.
Spreadsheet's an
Interesting.
interesting choice of a word though. Okay. So I guess you have range set and then
Hmm?
range clear, which is also range set. Right. Like there's no difference between clearing them and setting them to 0?
Well, I believe there can still be zeros in the spreadsheet, but no, zero means empty. Yeah, there is no difference between zero uh and empty. There cannot be zero as a value, I believe.
Okay.
Mm-hmm.
So yeah, so effectively like you just have range set and
Yep.
you want to make some array with the minimum number of range sets.
Mm-hmm. Interesting. Do you have any limitations on what kind of input there can be, or is it just like a random input from the spreadsheet? Whatever values there are, we can get it.
Yeah, so you're given basically it looks like some array. And the
Okay.
question is what's the minimum number of range sets you need to get this arbitrary array?
Mm-hmm.
But very, very notably, the size of the array is at most 800. So
Oh,
it's at
that's
most
not
800
much.
elements. Yeah. So it's not like we need to find some greedy way of doing this
Mm-hmm.
in linear time. We can be much slower.
Okay. So what are my initial thoughts? Well, obviously, we can always just take every single cell as a separate value and set it individually. So this is our absolute upper bound. There is no reason for us to ever go about the number of non-zero values in the given input. Then every time we have, um, well, uh, our operation, for whatever reason, probably because you just mentioned like segment trees and stuff, uh, I expected the operation to be like update on a range, as in not set them all to equal value, but I don't know, add a fixed value everywhere.
Yeah,
And
but it's
no, it's
not,
much
right?
easier.
It's range set.
Uh-huh. Oh, I have first to solve from our current leaders team Ipatsu. They now have 8 and they solved problem L. Just updating spectators on WhatsApp. So,
So real quick, someone here is saying DP and N squared, but like they're important details still, right? Like what is the DP and how do you do it in N squared? Like what is your state? But anyway, sorry. Continue,
no,
Lydia. Yeah.
they're welcome to elaborate. So, but instead, we are only allowed to just actually literally set a range. So, if you have a number of cells with the same value, that's great. We'll just set them all at once. And we can make it as our very last actions, as in we don't really need to do that early. Like if we have 10 ones in a row, this will be one of our last actions. And it's nice because it won't have any intersections with any others. So this is a plus. But on the other hand,
Yeah,
I
so I guess
intuitively
just
want
to
to select as many of them as possible. So if we select all of the cells that have the same dedicated value, we'll then have to, patchwork our way through the rectangle that we've built to make sure that each of the values requested will be manually built, which is weird. It requires some weird shaping.
so like one of the things you mentioned was like if you have consecutive twos, for example,
Mm-hmm.
then you can merge them together because you would never if you have two things that are the same, you would never set them to different things. They'll always just stay equal.
Mm-hmm.
So consecutive equal elements can be merged. And then the like one way of looking at this is when you overwrite some range, if you're ever able to at the very least like construct a like if you look at the places that you paint at the end when you're done, right? If you imagine like painting a stroke, these will make a tree always. You'll have a tree
Mm-hmm.
structure of them because
Yeah,
although the
otherwise
two
then there's no
ranges could
reason to overpaint the other end.
yeah, like if you have two ranges that overlap, there's no reason for them to overlap like that because you're overwriting the second half of the
Mm-hmm.
first one.
Mm-hmm.
So you might as well just stop them early. So you'll always have like some sort of tree structure of the ones that you paint.
Yep.
So now can you like and then if you have a tree structure, just the number of strokes is your answer, right?
Mm-hmm.
Um but the question that's remaining is like, can you get all the tree structures with a DP and N squared easily? Like, is that something that's doable?
Do we need to? 800
Maybe.
is pretty low limitation. We can do
N cubed, maybe?
n cube, I think.
Do we have a time limit? What is the time limit? Do they tell us?
I don't have it in the interface, but oh, it's actually 4 seconds on OpenCADIS.
Ah, so that does
That's a
scream N
lot.
cubed.
Yeah, that's a lot.
Yeah.
So yeah, to whoever was commenting that it's n squared DP, I'm not buying.
Omar, give us more details. If it is N squared DP, show us how we can get there because it seems like you may be smarter than judges if you can find a way of doing that. Otherwise, if I was a judge, I would have made bounds at least 2,000.
Well, judges do not have to actually set a problem as difficult as it can be. It's sad to actually waste a problem that has a more elegant solution and only requires something intermediate. But on the other hand, well, if it's necessary for contest balance, then probably it's just worth it, and they should go for it.
Yeah, it's true. I was looking at one of the earlier problems, something about like candy distribution.
Mm-hmm.
I thought I had a greedy solution to it, which was pretty simple, but it's possible I was wrong because just from reading body language, when Nick came in, he was like, "Oh, you should submit that and see what happens." And I'm like, "Okay, well,
There
if
is
that's the response, then it seems like the answer is probably not, but we'll
so
see."
another fun question that I would like to know about Pacific Northwest. How many incorrect submissions do you have? Because uh, Mid Central has barely no incorrect submissions on the easier problems. Well, probably like for problem G, 78 solves one incorrect submission. For problems C and I, 65 and 68 solves 4 or 7 incorrect submissions. So there is literally not an early game problem that turned out to be, weird, to have this tricky corner case that every team that was not ready for that will fail on. They were actually apparently pretty straightforward. And reading the problems, they are apparently pretty straightforward.
Lydia, I'm looking at our scoreboard now, and I don't know that I'd call it a bloodbath, but I certainly wouldn't feel comfortable submitting to CFG, uh, I, or K.
Oops.
So yeah, C has it looks like 2 or 3 times as many wrong submissions as AC's. F is like 1 and 1. I has 2 wrongs, no corrects. H or G has 1 wrong, no
Mm-hmm.
corrects, and K has 1 wrong and 4 corrects.
Oof.
So and these are like, to be clear, like most of those are teams at the top of the scoreboard too, right? So
Mm-hmm.
those are like the teams knew what they were doing and then still got them wrong, which means, oh, B also has an AC. I guess maybe that happened earlier, but we got
Yay.
dark green for D
Oh,
by Stanford Cardinal.
congrats. Oh, this is excellent. I
It
wonder
looks like,
how long was their solution testing. But sure.
yeah, sorry. It looks like other teams are starting to get H as well. It's starting to get on the scoreboard, despite the early 35-minute solve. Okay, Omar is a newbie. I don't know if he's joking or he's serious about this when he said easy n squared DP. Omar, if you have a solution to this n squared DP, give it to us. If you don't, if you're just like suspecting that it's n squared, that's totally fine. But I'm just curious. If you're a newbie outsmarting us, all the best to you. Right? Some days I feel like I should be a newbie, but yeah, no, it's a date, and we got just 3 more. The sword refresh, 3 more wrong answers, Lydia. So it's brutal
Oh,
over here.
okay. Sending my energy to teams in Pacific Northwest. Apparently, I was taking a good care of Mid Central, and they did things well. We have very successful leader teams specifically because once again, Urbana Champaign has been just rocking it, even though they just submitted B incorrectly, and even though problem L was, well, obviously not easy, even though they solved it in 100 minutes. 6 incorrect attempts, probably not something that they dreamt about, but also still a very nice lead, very nice advantage, like one solved problem over the second place, like pretty clear pace, and the easier problem they went through without any hiccups. So, well, a lot of
What is your
fun.
problem B,
My
by the way, if you don't mind me
problem
asking?
B is the range editing.
Ah, okay, okay. So
So
yeah,
no
it looks like
solutions
we
yet, but 1, 2, 3, 4, 5 teams out of top 10 are actually, I believe, working on it actively and for a pretty long time.
it looks like that will turn out to be a medium/medium hard problem in your set, if I had to guess.
Well,
Because
yes.
Urbana Champaign, they're at like a similar level to UBC, right?
Mm-hmm.
So at least in like by World Finals performance historically. And UBC has gotten 3 of their UBC problems. Uh
Hmm.
3 of the UBC teams, sorry, have gotten H. So I don't know. I'd be surprised. Like I would expect them to figure out what's wrong with their H and get it later on.
Yeah,
If I
but
had to guess.
my concern is, well, we have B, that's range editing, and that's okay, a lot of incorrect submissions. Teams will spend a lot of time on that. We have F, that was untouched by anyone so far in the lead. And we have K, that has an off submission here and there, but also not solved. But that's it. Team Ipatsu from Urbana Champaign has 8 already submissions on B, already solvable D that their schoolmates from Unbingeable already solved, and then just two more problems. I'm pretty scared about their performance. This seems very dominant.
Well, we'll see. We'll see. At the very least, it'll be a fight between some UBC teams.
Yeah,
Thank you so
should
much,
be
Lydia,
fun.
for joining.
Thank
You wanna
you.
say goodbye here, and we'll head off.
Yay! See you soon, everyone. Absolutely tune to our broadcast. We have a few more broadcasts scheduled uh, for the next 2 weeks. So hopefully, this YouTube channel will still entertain you with something very exciting. And yeah, best of luck with all the incorrect submissions. I wish them all gone.
Well, well, they'll keep working for the next 2 hours or 3 hours or so. All right, thanks, Lydia. See you around.
Yeah, bye bye. at another problem, maybe? Is something easy? I'm not the biggest fan of complicated questions. I'm a huge fan of, these exciting, easy problems that are solved by our contestants at the very beginning of the contest, just within a few easy minutes. I feel like this problem specifically always help us to promote the community, and the general idea of problem solving. And so ACGHI seemed like something very exciting for our contestants. I'm a huge fan. I'm always thankful for judges for preparing these problems. And if you're actually joining the open contest and solving these problems yourself, you'll be able to see that each problem is attributed to a specific judge. So, for example, problem A. Oh, I'm sorry, I was alt tabbed from the appropriate webpage. So, for example, problem A. In the metadata page is attributed to Nick Wu, one of ICPC World Finals analysts, as well as medalists and other. And then if we look at, for example, problem C, it's created by Nick as well. But then for problem, in just a second, have G, H, I, and J, right? Well, turns out apparently all of them are prepared by the one and only author of a lot of problems on North America qualifier, Nick Wu, which I'm very helpful for. It's great to see so many problems solved at the very beginning of the contest, and in general, be able to see our contestants work with them. In a few minutes, we'll be joined by another special guest, one of the judges for the contest. So stay tuned. We'll be right back. And for now, we have an extra moment to follow the scoreboard. fortunate to introduce to you my incredible guest for today. So please, everyone, meet Christian Lim, one of the judges for Mid Central Contest and also a coach for ICPC World Finals teams. So a person of many talents, and I hope that together with Christian, we'll be able to introduce you to some of the more exciting parts of ICPC. Great to have you here.
Yeah, sure, of course. Thanks, Lydia. I'm happy to be here, of course, and it's quite a pleasure to work with you every single time. So,
Oh, the pleasure is mine. So in today's contest, we have L problems. Have you tried solving all of them in a competitive style? Well, obviously, as part of the preparation for the contest.
yeah, so I tried maybe solving. Like, I mean, I looked at the solution for most of them, but some of the easy ones I can probably explain. Some of the hard ones, probably not.
Oh, this is excellent. In general, I feel like easier problems are probably even more important for regional level contests because if teams have something exciting to solve on their first, experience with competitive programming in ICPC in general, this brings them back. It makes sure that they will come back next year and we'll see them better and smarter and we'll see them solve more problems. So that's just a
Mhm.
lot of fun.
Yeah, absolutely. And one of the things that we actually try to do as a judges, so there are 4 to 5 judges for Mid Central. The problem A we were working on, so that like A is probably the easiest one, or we hope that a lot of teams will get it actually, and then
Mhm.
we randomize pretty much the rest. So yeah.
Oh, that's nice. Let's actually talk about problem A. I currently have it on my screen, so I can read it for you, and then share maybe a few words about the problem preparation process, the
Mhm.
way that you start with an idea and then you end up with the whole archive of problems. Uh,
Yeah, sure.
the problem is called rampant growth. So Eddie is planting his garden, which can be represented as a grid. He wants his garden to have exactly one plant in each column. And to make sure that plants do not compete for resources, two plants, if they're in adjacent columns, they must be in different rows.
Mhm.
You need to compute a number of ways to place these plants in a garden to follow the conditions above, and two ways that are considered different if one square has a plant and one arrangement but does not have a plant in the other. So you don't have to try and compare different arrangements by rotations or something. This is just a distinct arrangement. And just for the fun's use of this, because the number of these arrangements may be very large, you need to output it modular some 9 digits, which is
Sure.
always a nice touch to every competitive programming problem, because I've seen a lot of bugs exactly in this area of just
Mhm.
not calculating the answer, but making sure that it's properly taken modular given number.
Yep.
Well, and my first intuitional thought about the statement is like, are we trying to arrange queens on a chessboard again or something
Mm.
like this? So it
Mhm.
feels like a type of problem that we somewhat saw,
Mhm.
but also something pretty unique because of this very specific group.
Right. So I think that as a judge, when I actually saw this problem, well, I thought about like perhaps 2 different ways. One is, I guess the constraint is small, right? R and C are both small, so that makes us think, well, would that be maybe a dynamic programming problem, right? Like it's quite natural to think that way. Another way to think about it is, like just suppose that we have 2 columns and then try to think about what the answer should be, given we have our choices for the first one. Now, what do we have for the second guy? Well, we know that we can place it anywhere except where the first one is chosen in the first column. And so we have R minus one choice for the second one, right? And the fun thing is, I guess on this one, the for all the other columns that we have, third and so on, we can actually have the same R minus one choices for the rest because we just want to make sure that we don't have any conflict amongst nearby, like only the neighbors, not on all the other columns, right? So that makes us basically have the reasonably nice formula, which is r times r minus 1 to the c minus 1. Given that we have more than 2 columns, and now for the case of like some edge cases, right? Well, where we have c equal to 1 or otherwise, or r equal to 1 and otherwise, we have a explicit answer, which is let's say like if c is greater than equal to 2, but then r is equal to 1, then you only have one as 0 answer because we cannot place any of them, right? And otherwise, so there are some corner cases to consider, but the general formula will be something like r times r minus 1 to the c minus 1. So if we can derive that, then we can derive the solution explicitly for this question. And so a lot of, I think that judges actually came up with this formula, and then but I think that one of the solutions that we found is dynamic programming approach, where we just think about what to do for the second column, and after knowing that we have the answer for the previous columns. Right? Yeah.
Makes a lot of sense. Oh, I have an urgent update on Mid Central contest. So the team that was leading the contest throughout the whole last hour actually currently has 2 problems lead over the second place because they just finished problem D, which was not the first to solve. They knew that this problem is solvable. D was first solved 58 minutes into the contest, and it took our leaders just 127 minutes to figure out enough time to actually work on this problem. So now the first place has 9 problems solved, second place has 7 problems solved, and then comes the group with 6 problems solved, which is a very significant lead just barely 2 hours into the contest.
Yeah, and it seems like as expected, the range editing, which I think I was actually hearing you and I guess
David?
second thread.
Yeah.
David, going over, and then it seems like no solution yet, which I guess is expected given the difficulty of the solution, the problem.
But a very elegant problem model, as in it's pretty easy to understand in general what's going on with the problem, and so you can self-focus all your attention on actually trying to figure out this, which I enjoy a lot.
Yeah, for sure. So the B was and I guess the one of the things that I think David was mentioning is why do we have a spreadsheet cells instead of like just a list of numbers? And I think that it's just the person who is proposing the question. He wanted to really he thought about it using spreadsheet when he actually came up with the question. That's why I guess some of the questions they have the original meaning or intended like the way that they thought about the question, not necessarily like how it can be presented. Right. So.
Right. I can absolutely also see this spreadsheet process from problem B as a spreadsheet coloring. You need to draw a specific colored shape. And obviously you can color every cell specifically, but you want to make it more effective. You can group some of the cells that are nearby. And this seems like an intuitive approach if you're actually practically doing that. But then as soon as you try to build a programming contest problem out of this, you're trying to challenge yourself with what would be the optimal? When should I actually color also the cells with the same color from the other part of this line or whatever spreadsheet rectangle? So it feels very intuitive for me, and I appreciate that kinds of problem state. It just absolutely makes sense.
Yeah, absolutely. And I think that one thing that I should note is I guess as the Mid Central region, we are always looking for judges. So anyone who is watching who wants to be a judge, welcome to join us. So.
Hey, this is an excellent point. In general, programming contests are prepared by volunteers. And these volunteers, as well as judges, technical team, and even live streamers, they come from all walks of life. And if you feel like competitive programming is enough of your passion, absolutely join us in preparing contests. It may seem like it's very scary, and the only way to become a judge is to be one of these, top 10 contestants in the world, but it's absolutely not true. Every judging team is very welcome to have more new members and to get some more new ideas, because we're all here for a new set of unique problems. We have team looking for the backup from Vanderbilt University actually just submitted problem D and they got accepted, which means they're in the second place and they are now in between. They are now an Illinois at Urbana-Champaign sandwich with Vanderbilt University in the middle.
Mm.
So pretty tough competition. And what surprised me the most is just four penalty minutes difference between second and third place.
Mhm.
I very much hope that they are not actively competing by this, second or third place placement uh, for the North America Championship advancement. There should be enough teams for them um, to actually invite all of them if appropriate, but also Team Invincible is once again, unfortunately for them, the second team of University of Illinois to Urbana-Champaign. So there is no easy way for them to just be better than look for the backup and advance to
Sure.
North America Championship. But still, just 4 minutes penalty time, basically photo finish.
Yeah.
Very exciting.
And so there are three teams from the regional that are going definitively, and then there's one or two wild cards depending on how the allocation works. So that means probably UIUC going, Vanderbilt going, and Chicago going. If you were to finish right now, of course, things will change over time, right? So.
Yeah. We're not even at half the contest, so still a lot of
Exactly.
changes possible. Well, do not expect changes at the same pace we had the first hour ago, because as we've already mentioned, easy problems are already solved. And every next problem will probably require like an hour of coding time or at least an hour of thinking. So that's a lot of work. In the meantime, I would love to move on to problem C, which is also one of the easier problems. I'm a huge fan of easy problems. Easy problems can be understood through YouTube broadcasts.
Mhm.
More complicated problems, well, never like this. Um, how do you read the Champernowne verification? Oof.
Ah,
This is rough.
Champeroni. I'm not. Probably you're better at pronouncing it than myself, but the Champeroni, I don't know.
Okay, let's make it Champernowne. So
Yeah.
we are building the Champernowne numbers by concatenating consecutively going positive integers, starting with 1 and going up to however many we need. And the problem is to identify if given positive integer is actually a Champernowne word, and if so, which one? By the number, apparently. And we know that Championoni's words always start with 1. So it's not like you need to identify if this word started with 1 and went to 101, or it started with 101 or 123 and went up. So we have a pretty limited number of Champernoni's words. So it should be pretty easy to identify them, right?
Hmm.
I
Yeah. So I mean,
guess that the answer is just reading from left to right. If we consider reading this not as a number but as a string instead, problem seems to be pretty straightforward.
yeah. I mean, I guess I guess one thing that I tried when I was actually coding up this solution. I mean, because the n is only up to 10 to the 9, right? So,
Mm-hmm.
and then since it goes up in a sort of, let's say, quadratic way, so you can actually just append all the digits one by one, and then just
Mm-hmm.
check how many of them actually equals the want digit that we want at the end, and then that'll actually do the trick. So that's one thing you can do, and that actually works out.
There is another approach to this problem that is a little artificial for this specific one, but in general, I feel is very useful and can come in handy in other programming competitions and even in this contest as well. So
Mhm.
sometimes calculating the answer is difficult, but checking the answer is easy. And this case, as already mentioned, are limitations in the problem with n up to 10 to 9 are
Mhm.
actually very nice to us. Think of 10 to 9. How many digits are there? Not too many. So if we try and actually build all Champernowne words, it will not take too long for us to list all of them up to 10 to 9.
Mhm.
But then, even better, even if the calculation itself was very, very computer heavy, and would take a lot of computer time, we still can do that, what we call it, offline on your contestant's computer. So not on the side of contest control system, but literally just on your computer, even if it takes 5 minutes, no problems. Write a stupid solution, make it run for 5 minutes while your colleague is typing another problem. This is going to be absolutely fine. And then you pre-calculate all possible answers, store them literally in a static array within your code. This is sounds very stupid, sounds very contra software engineering practice, but it's a really sturdy approach for not just for competitive programming, but surprisingly, it is used in a lot of game graphical engines because you know what? It's very complex. It takes a lot of time to calculate sin or cosine. And so you just store standard values for however many um, arguments you are able to. And then surprisingly, your rendering takes significantly less time. And this approach can absolutely also be used in here because I can, if a number is within already given static array, it's pretty easy.
Right. So I guess the pre-computation, I guess the Lydia puts it, I guess is the second answer for sure. And I guess either one, that makes up for the solution for C.
Yep. Problem C was solved by a lot of teams. I'm very happy to see that. If we look at our statistics, exactly 69 nice teams already solved that, and only 4 is still struggling to try to figure out their bugs, but I'm sure they will be able to get through them in the upcoming minutes. And we will have roughly, yeah, actually, we just got a submission on problem C from a team from 72nd place, so good for them. It will be their third problem if they solve it. So good job. Very nice problem. Very enjoyable in my opinion as well as has multiple approaches. So what else can we wish for? What would be our next problem from the easier problem set? Problem G we've already discussed. So how do you feel about problem H maybe?
H or maybe I? Have you discussed I before?
No, I haven't. I is even better.
Yeah, I has a more solves that makes me comfortable, I guess.
Oh, absolutely. I is on our screen, so let me read through it. So Ashley's training for a programming contest on Brandon's online judge. Oh, it's nice to have heroes over a problem called A and B, very convenient. And has a new feature which allows Ashley's coach, Tom, to load a list of problems for Ashley. Tom has curated some problems for Ashley to work on. Each problem has 2 integers as a lower skill bound and an upper skill bound, and each programmer has an integer specific skill level, so no variation in. If someone with a skill level between lower and upper bound of this given problem and they solve the problem, a skill level goes up by 1. And Ashley needs to either solve or skip every problem on the list given by her coach exactly in the order that they were given. And a problem once skipped will never be ever looked again. This is not a competitive programming training advice. Please do not consider this problem as a role model of how you should train. Absolutely always go back to the problems that turned out to be too difficult for you or probably too easy for you as well. And upsolve them. It will increase your skill level significantly. Compute the maximum skill level Ashley can have if she chooses to solve or skip problems optimally. Excellent. This seems like a pretty straightforward left to right for problem. Because if you ever hit a problem correctly, so if problem matches your skill level, you should always solve it. There is no reason for you to skip it ever. And then we just need to carefully maintain current Ashley skill level, and you will be good to go. Once again, we read from the left to the right. We start with Ashley's skill level at
Yes.
at what? Now it's time for me to actually read input and output. S is Ashley's current skill level. And then if it is between L and R of each next line, we increase it by 1. Otherwise, we skip. And this sounds like a very nice problem to solve.
Yeah, so I think on this one, the crux is noticing that, as Lydia mentioned, the greedy solution wins. As in, if you can solve it, please solve it. And don't skip the question if you can solve it. And that's really the rule of the game. So, like given N and S and inputs that are given as pairs of L and R, if you can solve the current problem, which you can check by L less than equal to S and S less than equal to R, if you can solve it, then please solve it, meaning you increment your S by S plus plus, so S becomes 1 more. And then at the end, what you output is the eventual S that you get after running through n inputs of L and R pairs, right? So, yep.
Nice. Very, very pretty, very intuitive. Once again, very, very intuitive model as well. I mean, the idea of problem difficulty is very clear, and our contestants may have seen that on online judges in person. So, a very nice example that also promotes the idea of training for programming competitions. What
Yep.
else can we wish for?
Yeah, but I guess except as you said in the actual training, you probably ought to solve the questions that you actually didn't get to solve during the contest.
Yeah, absolutely. And then I think that we also have, um, yeah, basically the 4 main problems of the contest that are solved by most of our contestants. Which ones were different when they were initially conceived by problem authors, or do you feel like these problems began the same way they ended up giving to our contestants?
Yeah, so the ones A, C, and G, and I, right? Those are the 4s that we think would be fairly easy for people to solve. And then I think that they are actually, in fact, turns out to be the easier ones out of the, I guess, well, in some sense, I guess all the teams actually recognize that those are the easy ones. Although I guess we have currently a little bit lower counts on A, but I'm sure that'll change, because I expect that it'll go probably in the orders of 70 and 80 pretty soon once they realize, oh, it's actually not as hard as queen placement problem and otherwise.
Yeah, I agree. This sounds very nice. Do you, as we've noticed in the online judge, I think all of these problems were prepared by Nick Wu. Do you think there is a specific bias that sometimes there is a specific judge that sets your problems, or is it something that actually depends on whatever this specific contest?
I think it's possible that some of the problems, as you mentioned, I was actually watching the live stream, and then I think it was mentioned that they want to save it for later, right? For more difficult problem set later. So North America Championship or World Finals and such. So some of them, I think that they made such a call, and then for the easier ones, I guess people can kind of recognize that, oh yeah, so those are easier ones, so we kind of include them in the set and such, right? So I think those are made on sort of like case by case basis, but we kind of all come to similar conclusion, as in, oh, those are definitely the problems that we definitely want to use or not, and those are definitely decided by collectively amongst the judges for at least in the Mid Central case. I think it was Etienne, Jingbo, who is a head judge, and Rachel, Danny, myself, and Ed, who is a regional contest director, right?
Nice. Is there someone on your judging team who always comes up with the most difficult problem of the contest? In my experience, we have 2 of such judges in Northern Eurasia who, because of the structure of their work, read a lot of up-to-date scientific papers, either on algorithms, so data structures, or whatever information. And then it turns out that roughly once a year, they are usually the ones to attend judges' meeting and bring in the most hilariously difficult problems of the year.
Yes, I think amongst the mid central or the problem pool that I've seen, I don't think I've seen such a problems, but I can tell you, the Greater New York, because I'm actually coaching for the Columbia team at the same time, and then when I see some of the problems, one of the problem is geometry, and I know that the geometry problem is one of the fun problem that I guess Greater New York Regional and actually East Division I think is going to set in the future. And so what I heard is only one person in the region sets the pretty much like a crazy difficult problem for geometry every year. And then the funny thing is, I think one of the problem was actually reused multiple times, yet no one solved it, even after trying that exactly same problem multiple times, right? So I think that's probably the fun one that I can remember.
Oh, this is exciting. Indeed, contestants are usually not the biggest fans of computational geometry problems
Right.
because of a lot of technical tricks and nuances that they require to
Mhm.
actually solve the problem. Oh, we have a submission on B from our current leaders, Team Ipatsu. They've already tried solving this problem, so I'm not
Oh, that's
100% sure, and
ah,
they still
didn't make
getting
it.
time limit. And
Yeah, yeah.
this fits really nicely into our discussion with David. Said, well, the limitations of this problem's input are such that you somewhat think that probably an n square solution can squeeze in if there's a good constant parameter stuff. And then you try squeezing that, and then it does not work. So, well, looking forward to a lot many attempts on problem B. It's very surprising how our current leaders they breezed through all the easier problems of the contest. So they haven't had an incorrect submission up to 100th, no, up to no, yeah,
Yeah,
up
up
to
to 100. Yeah.
roughly the problem that they solved on minute
Oh,
100. So
127. Never mind. Yeah, yeah.
they had incorrect submissions on problem L, and actually quite a lot of them, 6. But
Yeah.
still, all the easier problems were just here, 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 done, 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 easy. And this is very nice. It gives them a nice upper hand on the competitors, and specifically, as we've already mentioned, on Unbingeable and APAC, because, well, it will be really difficult to catch up with Ipatsu if you are currently 2 or even 3 problems behind, and your penalty time is roughly at the same level as they have it.
Mhm, mhm. And I think it seems like the UIUC has 3 problems to go for 2.5 hour mark that we just passed. So I think they might be able to all kill. Let's hope.
Oh, this is exactly the middle of the contest. And well, starting at this point, we don't see too many submissions from our leaders. Once again, the joke is that it's very important to read all the problems in the problem set. Why? Well, kind of you kind of upload these problems to your brain, and then even while you're typing another problem, you actually continue actively working on all the problems that you've seen in the contest, but just trying to figure out the right approach, or your brain just try to identify something um, similar in topic or approach that you've probably seen before. And as we go through the first half, at this point, each contestant absolutely have read all the problems remaining in the problem set. It's very fun how sometimes easier problems may not even get read by one of the contestants, because our contestants receive a set of paper statements, and then they have to work through paper statements. And um, the fun thing is that if you solve the problem, you just throw away this piece of paper. Why would you ever keep this? Do you do the same when you solve problems? Do you identify solved problems as something so that your contestants are either never reading these or they just don't know what they are? And this is a lot of fun. There are a lot of strategy pieces around the idea that ICPC is a team competition. So there are so many unique and distinct features if compared to an online judge or an individual Olympiad in informatics as well. So it's a lot of fun to see how teams find themselves in this kind of deviations and once again limitations of the format as well.
Mhm, mhm. Yeah, absolutely. I think that's what makes it fun, right? The team building and also interacting with other schools, and then build a friendship that last. Actually, what I can recall is like when I made a friendship back in 2010 for when I was competing in the regional. I think I do connect with some of them still. So
Oh, I hope that our teams will connect to their, well, both teammates and peers from the same competition in the future. And it's very nice now to be able to also share some of the problems across regional contests, because
Mhm.
finally, this is a really nice reason for them to talk to each other, even if they participated in different regional contests. There is something to discuss over, and there is a lot of ways and interesting approaches to discuss it. And our contestants have multiple ways to do so. First of all, there is a dedicated Discord server specifically for ICPC contestants in Northern Eurasia. So this can be a nice platform for either our spectators or obviously our contestants to join, as well as we've built and are currently working on a dedicated Facebook group. So if you're looking for a place to subscribe to get all the latest updates, but a very limited amount of them, absolutely follow us on the web on Facebook group at na.icpc.global. We'll try to keep you posted on all the latest advancements, as well as information about which teams actually advance from regional contests to North America Championship. So this should be exciting. And as well as all the online judges that are available here and there should be able to follow them.
yeah, absolutely.
Hey, what would you recommend to teams that, well, are not actively participating in the contest right now, but are looking forward to joining ICPC already this autumn? So the next time regional contests are held.
Yeah, so I think first of all, I think there are opportunities for you to train. I guess through, well, I'm not sure if I can reveal those names, but Code Forces, Headquarter, I guess or Caddis that we are using, right? So we can train up using those platforms for sure for training, and also through the ICPC internship, you guys can actually train through as an intern, as a problem solvers too. So if you like, you can feel free to send an email to internship@icpc.foundation and definitely get involved if you'd like. So, and then for those of you who are looking for sponsorship post your studying as an undergraduate and graduate, especially as international students and or if you are domestic students with a permanent resident or U.S. citizenship, you can reach out to get involved for sure. So yeah, that's one way. And for those of you who are actively participating and want to get involved as a problem setters, judges, and potentially testers and so on, then you can actually reach out to any of us, actually, Lydia, probably myself, and otherwise.
Absolutely. Thank you very much for joining us. I'm looking forward to the second half of the contest. Do you want to try to guess and predict how many problems will the leaders have at the end of the contest?
So I think given the current things, ways that we are going in the mid central, I want to say maybe shy of one, they can solve everything. So 11 maybe, but 11 or 12 would be my guess, right? So there are in total 12 problems here, right? So I think that's probably a reasonable guess. But if I were to guess between 11 and 12, yeah, why don't we go with 12 and then give I guess the teams like some hard work to do.
Yay! That's a nice prediction. Thank you very much for joining
Yeah,
us. And
for
stay
sure. Yeah.
tuned for the live broadcast as we come back. Bye bye.
Yeah. Thanks, Lydia.
And here I am with a new guest for our live broadcast. I'm very happy to introduce you to Dr. Edward Corwin, Director of Mid Central Contest. Ed, it's so nice to have you here. Am I right that this means that the contest runs smoothly and you don't have anything more important to do?
It it had a couple little glitches right before it started, but since it started, as far as I know, things have been going very well.
Good job. Congratulations. I think that with half the contest behind, this means that it's a job well done so far, and I'm very much looking forward to the second half of the contest.
Yeah, and all all thanks to the judges who, as far as I can tell, created a very nice problem set in terms of the number of teams that have solved at least one, and the fact that the top teams still have some work to do. And many thanks to the other folks, the Caddis folks. We had 3 or 4 teams that changed contestants this morning,
Hmm.
and the Caddis logins were based on the contestants on the teams, not specific team logins for the contest. And so they had to update the team list in Caddis this morning for 5 different regions, and they got it done. Pretty amazing.
Well, sounds indeed perfect. And doing all this together with running open contests for each of these regions, for all of these divisions, and giving our spectators an opportunity to actually test themselves against the same problems that are given to contestants. This is a very exciting
Mm-hmm.
opportunity. I'm very thankful
Yep,
for
yep,
all the teams involved. I think it's a great result,
yep.
as well as it's a great promotion for competitive programming and
Oh
ICBC
yeah.
in particular.
And so a lot of thanks to Frederick Niemela and Greg Hammerly and the rest of their crew. Those are the 2 names that jump to my mind, but I would guess that there are a bunch of other folks helping out there.
Absolutely. Uh, and the other people that I feel like I have not dedicated enough attention so far are contest organizers from all the various sites. We have um, how many teams compete today in Mid Central contest?
We had 87 teams registered. There are 5 or 6 teams that haven't submitted anything yet,
Mhm.
and so I don't know if that means that they're having a hard time or if they just didn't show up. There are always a couple of teams that decide at the last minute they're just not interested in competing, or people get sick or things come up in people's lives.
Mhm.
But I honestly don't know about the 6 teams that haven't submitted anything, but we did have 87 teams registered.
And each of this
And
team is currently solving a contest at location at identical contest image, which is not a small feat uh, to do. This is an impressive amount of technical and organizational work from uh, host universities that welcomed ICBC regional contests to their sites, and it's very exciting
and the
to have more
yeah,
of them this year.
running a site has gotten harder over time. You would think that it would get easier, but I guess I wanted to give a shout out to, what do I have here? 7 different universities that are running sites this year. I have Illinois at Urbana-Champaign, University of Kentucky, Arkansas Fort Smith, Southeast Missouri State, Tennessee Tech, Purdue Northwest. And you might think that, wait a minute, they're in Indiana, they're not in my region, but they are in suburban Chicago. And so technically they are in my region, and University of Tennessee at Martin. And special thanks to Jersey, the longtime coach at University of Kentucky. We didn't have a Kentucky site until just a few weeks ago, and Jersey managed to talk his department into hosting a site with the more and more schools going to labs that are bring your own PC rather than we have a set up for you with everybody has the same computer. These days, you bring your laptop in and you put it down on a table or whatever, and you're in lab. And that doesn't work well for most people on the ICPC. And we've been talking about, okay, how are we going to make that work if that's the mode for more and more schools going forward? It's going to be interesting. Some regions have been able to manage to say you have to be able to put this thumb drive in and boot to this particular system, and we haven't been able to get that to work in our region yet, but that may be where we're headed next if we don't get more sites with actual PC labs. And so if anybody's out there watching this who has such a lab, even if you're not in Mid-Central, contact whatever region you're in and let people know that you might be able to host a site.
Do you feel like there is a positive correlation between hosting a site and performing well or advancing to North America Championship?
There's a little bit of a correlation in that often, like University of Illinois, it's a big school that tends to do well, and so they have the facilities, the resources to run a site. But most of the sites, in fact, in my region, are sort of smaller schools that typically don't do all that well, but they have fun in the contest, and they enjoy participating, and they have coaches, administrators, whatever, who value the contest, and that's what it really takes.
It's also, I presume, financially much more reliable to organize a site at your university as compared to making sure that every single year you have enough funding to travel your teams at the regional level event. But well, if you advance to North America Championship, that's a whole another travel funding situation because now you gotta travel to a single location. All the teams actually gathered together for North America Championship, and this year North America Championship will be hosted by UCF, I believe.
Yep, UCF in Orlando for, I think it's the third year in a row. They've been doing a great job, and they want to continue. And if they're doing a great job and they want to continue, we'll be there again. That's not my decision to make, but that was the decision for this year.
Sounds perfect. Do you feel like you have the same strategy with sites for Mid Central as well? Uh, is it true that being a site is usually a multi-year affair as opposed to a one-off experience?
Most sites, once they have run a site and see that it it has some problems to it, but it's not really a big deal to run a site, and they have fun doing it, and they do it year after year. It, in some ways, it's a good kind of PR tool that schools from whatever within 100 or 200 miles of your location send students to your campus that that can't hurt the visibility of your school. And so, yeah, there are schools that like to do it. Just it gets them some publicity. Gets students on campus who might be interested in transferring, going to graduate school there, whatever.
Which part of ICBC publicity do you consider to be, well, more useful in general or more useful specifically for you and your academic experience? So your team may perform well and this brings you publicity, or you may organize a significant competition and gain publicity this way. How do you feel this compares?
Yeah, I think you're right that both of those can get you some nice publicity. I guess I honestly don't know which one necessarily gets you better publicity. And I was coach for close to 40 years, and South Dakota School of Mines in Rapid City, and then we were able to talk ICPC folks into running the World Finals in Rapid City, and both of those things got great publicity for Rapid City and for the school. Probably running the World Finals got us more worldwide publicity, but in terms of getting publicity for students who might be interested in going there, I think the fact that the teams did well many years, that the word would filter down to students in high school who would say, hey, they must be a good place to go if they were 1, 2, 3, whatever in a large region. I think I'll go there. And we actually got students who came to our program specifically because we had a good programming team.
Oh, this is exciting. I feel like there are not too many opportunities for computer science students from different universities or schools to compete against each other, and having ICPC also focus on this regional aspect of it, and not just given the opportunity to the very short list of top rated universities, but also just have this incredibly wide range of universities participate, is a huge helpful endeavor. As well as an exciting story from my ACPC Live experience was that I was looking for the people from Mid Central region who knew the teams, who will be able to answer some of my questions to prepare for the live broadcast as well, like who are the favorites and others. And I identified that one of very prominent competitive programmers, originally from Swarthmore College, actually, as they graduated from Swarthmore, went to Chicago. So even though they changed their regions, ICPC wise, they still continued being at the very heart of the whole party, and they made sure to keep in touch, which is very nice. Christian also highlighted that he's still very much regularly talking or working together with people whom he met through programming competitions. And absolutely, regional contest is the place to go.
Yeah, it's nice to see that a lot of students will wind up becoming friends with other competitors from whether it's the same school or different schools. And at the North America Championship, we get students from schools from all over the country who get to talk to each other and find out that they have things in common and become friends. And the last few years, we've had teams that have as their team name something about another school. There was one school that had a name something like the University of Kentucky Fan Club, and that school was not from the University of Kentucky. They just had met folks from Kentucky and had gotten to be friends with them, and that was their team name, was University of Kentucky Fan Club. And I think I don't remember what the other school was, but I think the University of Kentucky team had a name that was related to the other school that was their fan club. It was kind of fun to see that there are friendships being made across the country.
Yep, this is very sweet. Another category that was most meaningful for me personally, as I actually never competed in ICPC, but instead, since my freshman year, I was volunteering as a student volunteer at International Collegiate Programming Contest events from regional level to world finals. And we've already gave a shout out to the team of judges, incredible university hosts, but also there is a huge number of student volunteers who help with, things that may seem obvious, as in probably even easy, distributing problem statements when they're printed, making sure that team registration is fast and smooth, and all these tiny details that all build into the general feel of how ICPC should be run. And I feel like these connections are also, well, they were very meaningful for me, as the people that we worked together with as part of student volunteer body of competitions became my great friends, and I'm now a huge fan. Oh, we are 2 hours, 57 minutes, and 17 seconds into the contest, and Team Ipatsu just submitted problem K. Problem K is not an easy problem, let me tell you. Surprisingly, there are currently multiple submissions on problem K in the queue, but Ipatsu actually got it. So they are now 10 problems solved. This was first successful submission on problem K in Mid Central. So they also get this beautiful star sign mark in the leaderboard in our live broadcast. And well, this is a very substantial lead. Uh, Ipatsu with 10 problems, and then we have 3 teams with 7 problems so far. Uh, look for the backup from Vanderbilt University and Benjable from uh, IUC, and then Jig Jack Attack from Chicago. 3 problems lead. Do you know anything about Team Ipatsu from Urbana-Champaign?
I I don't really know who they are. I checked out the names of the students a little while ago, and just looking at the names, it looked like they were from several different locations on the globe, but I couldn't swear to that. That's just a guess from what their names are. Uh, I would think that it would be a great idea to have a mix of talents, a mix of backgrounds in whatever ways you can to get as good a team as possible. But sometimes people work better together if they have the same background. So
Mm-hmm.
it's always hard to know what to do there, but I honestly don't know a whole lot about that team. I am. Oh, I wanted to mention, I think Christian might have said that the 3 teams advance, and it's actually
Ooh.
four teams, from 4 different schools are guaranteed to advance to the North America Championship.
Wow.
There
4
are
is exciting.
11 regions in North America, and roughly speaking, each one gets 4 teams. There are some regions that have banded together to form what we've been calling divisions, but we're still working on how to name these things. And so if your region is part of a division, then typically what those groups have done is say there are 3 teams from each region, and then the next, whatever, 3 or 4 from the overall scoreboard. And so most regions would still get 4, but you wouldn't be guaranteed 4.
Mm-hmm.
And that's sort of the better teams in some sense towards the North America Championship. And hopefully Mid Central will be joining with some other regions next year, but we still are trying to work out the kinks there as to exactly what the rules are. And as hopefully everybody knows, but maybe there are some newbies watching this thing, it's 4 different schools. We do not send 2 teams from the same school to the next level. So even though Illinois has teams in 1st, 3rd, and 6th, and Chicago has teams in 4th and 5th, they will only send 1 team to the North America Championship. So currently, if I'm reading this right, we have Illinois in 1st, Vanderbilt in 2nd, and then we skip the other Illinois team, Chicago in 4th, but that's the 3rd place school. And then we go down to Northwestern, currently in 7th, would be the 4th place school, not very much ahead of Illinois Institute of Technology and several other schools that are not that far behind. So the top 3 schools currently are Illinois, Vanderbilt, and Chicago, and that looks like they have a very good chance of being in the top 4 when all is said and done. But that 4th place, I think, is wide open at this point. Northwestern and Illinois Institute of Technology are clearly the 2 to watch there, but there are other teams that are down with 5 problems solved instead of 6 that could very easily wind up solving some problems that Missouri University of Science and Technology has 3 problems that they got wrong. If they can figure out what they did wrong on those 3, then they jump up to like second place. So
Yep.
that's what makes it exciting.
Yeah,
And I've been
scoreboard looks very interesting at this point.
I've been trying to listen to your your commentary as things go on. I have to mute you occasionally when something that comes up that I need to answer, but I'm very happy with how you make it sound as exciting as I think it is, and maybe even more exciting.
Oh, thank you so much. Uh, at this point, looking at the scoreboard and trying to guess the next move for each contest is probably my favorite part because there are logical parts to that, but there is also a lot of contestants' intuition put into the process. We can automatically say that, well, if everyone above you solved problem X, you should actually go and solve problem X. But surprisingly, the ability to look deeper into the problems is what actually decides the either advancement to the NAC in this case, but also advancement to ICPC World Finals and sometimes even World Championships. The way you trust your judgment on a specific problem. And as one of the contestants recently told me, um, sometimes when they rely on this intuition too much, it feels very scary because it's very nice to be able to prove a solution, but sometimes you don't have enough time for that. And you
Mm-hmm.
actually need, in order to win, you need to just trust yourselves. Make sure that your very non artificial intelligence have seen enough problems of the same kind to skip the proof part and go directly
Yeah,
to
yeah.
this solution will just work. I'm sure of it.
I still remember a long time ago, I looked at a problem when I was a coach trying to make sure that I could solve it to try to help my team solve it. I could not understand the problem at all. I looked at the solution, the not the solutions, the sample input and output,
Mm-hmm.
and I looked and went, their output seems to be 2 to the 2 to the n. And so I wrote up a quick little piece of code that computed 2 to the 2 to the n and ran it against the sample, and it said, "Yep, that's accepted." And I never did understand the problem, but I could solve it.
Oh, this is a lot of fun. This is something that only should be done by professionals. Please do not try that at home. Make sure that you have appropriate coaching and supervision for that. Uh,
And
but but probably
if
this is
you're
the fun
writing
part.
if you're writing life critical code, don't do that. If you're trying to solve a problem for the ICPC and you have no other way to solve it, try it. You don't get penalties on problems you don't solve.
Absolutely. There's a peculiar moment in the contest. So at minute 182, 183, we had 3 teams in a row solve problem J, which is also not one of the early game problems. J is a very serious mid game to late game problem of today. And all 3 of these teams are now in position 10, 11, and 12. So 3 in a row teams with different penalty times, with different number of incorrect attempts, with everything different, different universities and names. They are just now they took a step forward, solving problem J, and appeared at the very middle of this pack of teams who solved 6 problems, which is a very peculiar contest detail. This is not something you see often because, um, just as I said, a penalty time difference of 4 minutes is basically a photo finish. And this little maneuver with problem J, I see as something from, I don't know, synchronized uh, swimming or probably a figure
Yeah.
skating.
Yeah,
An
that just
action
doesn't happen.
of incredibly high synchronicity. Very random one at this.
And I do wonder for the easy problems if some of these teams are going to be really beating themselves up about not solving problem C in particular. I I misinterpreted what the judges had told me about the problem set, and I thought they had told me that problem A was the easiest problem. And I read through that and thought, yeah, that's easy, but it doesn't seem sort of easy enough to be the easiest. And then I read problem C and thought, wait a minute, there are only 9 possible correct answers.
Mm-hmm.
All you have to do is say, is it a 1? Is it a 1, 2? Is it 1, 2, 3? Is it 1, 2, 3, 4? Is it
Yep.
1, 2, 3, 4, 5? And after you check the 9 possibilities, say no. And so I'm not sure how it is that there are like 8 or 10 teams that have solved other problems, but have not solved that one.
Yep.
I think sometimes teams think that they have to be hard. It can't possibly be that easy. I have to come up with some dynamic programming approach to solve this problem, some kind of fancy tree structure or something, and not just have 9 if statements. That can't possibly be the right answer.
Mm-hmm. And I've somewhat enjoyed that a lot. The idea that teams are always misinterpreting the the difficulty. Some problems they think is very easy, but then the other problem is too difficult, but then oh, this problem was solved by almost everyone, so I should absolutely run there. Or for other teams, so for example, currently we don't have any successful submissions to problem B, but we still consistently see teams in the second 10th, between 10th and 20th position, try to solve it. At the same time, problem J is not solved for each of them yet. So these are tiny little strategic details, which they're not unfortunately finished. This is a lot of fun. I'm looking
Yeah,
forward to some scientific papers that actually document the effect of visible scoreboard on contestants.
it's also the case, and I used to try to make sure my teams understood this, that it's always possible that in their algorithms course, one school just covered exactly what they needed to solve a hard problem. And they look at that hard problem and they go, oh, we did that yesterday. And they do that one first and they get it right in 5 minutes or whatever. And then nobody else gets it right for an hour because it's a hard problem that they just luckily talked about the day before.
Mm-hmm.
And so just because some team solved it in 5 minutes doesn't mean it's an easy problem.
The idea of seeing problems before is also, I don't consider that luck. I I refuse to consider that luck. This is hard work. This is how you actually get good. You solve problems. You solve as many
Mm-hmm.
problems as you can. You try to remember as many of them as possible, and you increase the possibility of getting the problem that you solved within the last month by working hard, by
Right.
actually training hard. And um, every time someone like complains about the fact that this is a well-known problem or a problem that was recently on an online judge somewhere on the other side of the world, I feel like this is not exactly fair. This is the reward for reading all the books that you could find.
Mm-hmm. Yeah, it's a benefit of studying, which hopefully everybody has been studying and preparing and doing at least some checking of what's out there in the world of contests. I would guess that the teams that are near the bottom are just doing this for fun and perhaps haven't done a lot of, hey, wait a minute, this problem was on a regional last year somewhere. But the teams near the top should recognize problems that have been used many times before.
Right.
I do wonder what's going to happen with the the couple of problems that haven't been solved yet.
What would be
We
your
have-
guess? Oh, as I asked Christian to place a virtual bet on the number of problems solved by the first team, but for you, I have a more complicated question. How many teams? How many problems will be solved by the team in second place? What would be your idea for that?
Oh yeah, that is a tough one.
I have that
I would,
curveball up my sleeve just in case.
yeah, it looks like we have a little under 2 hours left, and the teams currently in 2, 3, 4 have 7.
Hmm?
I'd find it hard to believe that they will solve more than 9, but between 8 and 9, that's a tough one. I would hope that one of those would solve 9, but I would not be surprised if 8 wound up for second place. I'm hoping it doesn't wind up as 7.
Oh,
That
this
would
should
be
not. No,
kind.
absolutely impossible.
I wouldn't say impossible, but it is unlikely, and it will be kind of sad if teams 2, 3, 4 sat with 7 for an hour and 45 minutes.
I mean, I can
That's
understand
frustrating.
why the team Unbingeable from Illinois at Urbana-Champaign can just, just take their hands off the keyboard and decide that there is no way we can catch up 3+ problems. But
Right,
yeah,
they're
look
not
for the
going to
backup
advance.
and Jack Attacker not giving up so easy. So no. 7 is definitely not an answer I'm hoping for.
And it's always interesting that sort of psychology is the unbingeable team. Are they going to say, gee, we can't possibly beat our number one team, we're not going to advance, and so let's let's not bother? Or are they going to say, hey, wait a minute, we could beat Vanderbilt and University of Chicago and anybody else who starts to solve problems in the last hour here, and wind up with 2 Illinois teams, first and second. And wouldn't that be great for the school? Let's try to do that. And they might actually get more excited to solve extra problems. But psychology is always interesting in contests.
Right. Himipatsu from the first place continues uh, trying to persuade problem B to pass. This time they got wrong answer. Last time they got time limit. So still a few more incorrect verdict options to go. And hopefully they will either move on to problem F that is yet untouched by anyone in the contest, or will eventually figure out B that is not solved by anyone.
Yeah, there was actually a clarification request on problem B that said something like, hey, nobody's gotten this right. Are you sure you have the right answer?
Well, this
And
is the part of judges' work here.
and the judging team that we have now for North America is pretty awesome. And they're human. They could have made a mistake, but considering the the people involved and the number of people who write solutions and check solutions, I'm rather confident that the judge's solution is correct and the solutions that we're seeing from other teams are not correct. And I just to for my own benefit, I looked at several of the solutions that people had written and gotten wrong answers, and they all have different answers. So if the judges are wrong, it's not that there are a whole bunch of teams that are right. But I doubt that the judges are wrong. I was actually chief judge for North Central for a few years. And back then, I was the only judge. And I'm human. I occasionally make mistakes, and there were problems that, yeah, I had the wrong answer. And we had to fix that on the fly. And it was frustrating and annoying and whatever, but we did try to keep on stepping on this cord and threatening to dump something on the floor. And we, yeah, we fixed things and moved on. And then it made me feel a little better the 1 year that I wasn't the head judge. There were still problems. People are human, and when whatever it was 10, 15, 20 years ago, we would only have one person being the person to check these problems, and that doesn't work very well. But now we have a half a dozen or more really top-notch coders checking these problems. We don't get errors very often.
Well, we haven't got one in this contest specifically so far, which I think is exciting. And I would like to, I'm sure the end of the contest is always very, well, not stressful, but just full for every contest director, because there are so many things that need to be done exactly at the very end of the contest, all the decisions and processes. So we're unlikely to have a chance to congratulate you on an excellent gun contest that moment the contest is over. But I would like to give you a warm congratulation on 3 hours and 18 minutes and 33 seconds that so
Oh, thank
far
you.
ran absolutely beautifully. Thank you very much for organizing the contest and joining us for the live broadcast.
Thank you.
And we'll be back with some more fun scoreboard action in a few minutes after a short break. See you all very soon. hope you enjoy the cat stream. I would like to notice that we have an update in our leaderboard. We have a first solution for problem B, not the first solution over all regional contests, but the first solution in Mid Central. But this is surprisingly not from Ipatsu, but from a University of Chicago team AHH, I believe, that is currently in 11th place. This specific star sign is a little more complicated to see in our scoreboard because problem B corresponds to green, but it's still a very interesting advancement in our contest because, well, we saw a number of incorrect submissions on problem B from Ipatsu already, and so I somewhat expected that they should be the one to figure out the problem first, but surprisingly, a different team from a different institution altogether. This is very exciting. I'll be looking at this Chicago team now more closely because I think that with problem B in their bag, they currently actually have all the chances to go high up and advance a significant number of places within upcoming minutes. They don't need to solve well, an extra problem in a sense. They can continue working on the same problems, and even if they will be virtually one problem behind, that would still work for them. I figured that you might want to see a little more of Cat coming forward, so I will have to move my streaming station somewhere closer to the couch. Outside of this advancement, really not much going on. For example, in our open contest, we have a successful submission on problem B. It was actually submitted quite a long time ago by a team called Longest Subroutine from Wisconsin. I surprisingly, even though second thread mentioned that he's originally from Wisconsin, and this team represents University of Wisconsin-Madison. This is not a team that second thread personally participates in. They actually solved all the problems but problems F and problem K in an open contest. And as we know from our contest leaderboard, well, problem K is already solved by one of our teams. So this is a very interesting moment. This is very nice to be able to see how different teams actually estimate problem difficulty. Different and difficult. This is the keyword for our contest, just a little different, a little complicated to pronounce. In the meantime, still not much action on problem F. We have a submission attempt on problem F from a team with a particularly peculiar name, Team Meow from Northwestern University. And I feel for that team name. I feel like we'll be rooting specifically for Team Meow, even though they are currently in 5th place with 387 penalty minutes. An attempt on problem F is very interesting and definitely not expected from them as a given. We have submission to problem K from Vanderbilt University at the 2nd place, so look for backup. Are trying to solve this problem, but testing time for this specific submission is just a little too long. I'm afraid that this may not be the correct one, but rather probably a time limit, but we'll still see exactly how much time. Oh, this solution actually passed. Congratulations. So Vanderbilt University finished their incorrect submission with a correct one on problem K. So 213 minutes in. They are now in the 2nd place with a nice one problem lead over the 3rd place. So their space in the contest is now just this little bit more sure. at this point, we have 15 minutes until the free time. This means that in 15 minutes from now, we will stop receiving scoreboard updates with specific verdicts that our contestants submit. We will only receive information about the submission fact. Doesn't matter if the submission will be successful or unsuccessful, we will unfortunately only be able to see that the submission happened. This will allow us the following set of speculations and entertainment. We'll try to look at an optimistic scoreboard, a scoreboard that interprets every lost submission for a problem as an accepted. This will help us to estimate the maximum number of submissions that of problem solved that team can theoretically have on a given problem. At the same time, we will continue looking at the real scoreboard, which means that the teams in the scoreboard will not actually change their positions until we know that they solved the problem for sure, which will happen during the closing ceremony, during our resolver, or the process of revealing the correct and full leaderboard. At this point, though, we will theoretically be able to actually know who won the competition, because there is a possibility that teams in places number 2 and on will just not submit into enough different problems to overcome Team Ipatsu. Because every submission, every successful submission also adds to the penalty time. And currently, Team Ipatsu has pretty good penalty time. They only have 6 incorrect submissions over the whole contest on the problems that they solved. And they have 4 more incorrect submissions on problem B that they will, I guess, eventually also solve. And so, for example, Team Look for the backup will have to do significant work to overcome them. The contest duration in total, so 5 hours, is 300 minutes. And team from Vanderbilt University will not just have to solve 2 more problems, but they also will very probably have to solve 3 more problems and win by a specific number of problems solved instead of just the penalty time, because their penalty time will be worse than penalty time from Team Ipatsu. This is a pretty interesting detail in general, and as we will go through the contest specifically with the teams that are fighting for NAC advancement slot, and as we were informed by contest director himself, there is a guaranteed number of 4 slots that will be given to teams representing distinct universities to advance to North American Championship. So it's very likely to be University of Illinois at Urbana-Champaign, Vanderbilt University, University of Chicago, and Northwestern University. But there are things that still can affect significantly that. So, for example, currently 2 University of Chicago teams are in 4th and 5th place. Yes, they have different number of problems solved, but what if Team Orange Blue solve their next problem right now at 3 hour 50 minutes into the contest? 3 hour 50 minutes is 230 penalty minutes. They have very good penalty time at this point, just 163 minutes. Their total penalty time, if they submit a correct solution to a problem that they don't have incorrect submissions yet to, will bring their penalty time to 393, which means that they will be above Team Jack Attack that is currently in this University of Chicago advancement position. So the actual number of events that should happen to significantly change the teams that advance to North America Championship is pretty small. So I'm very much looking forward to that. Another change that can happen any minute now is the team from Northwestern University. The thing is, unfortunately, they're now in the middle of the pack for teams with 6 problems solved. And if some of these teams actually solve one more problem, they will go up to, well, either third, fourth, or fifth place, because currently we have two teams with 7 problems solved in third and fourth place. So instead of Northwestern University, for example, a team from Illinois Institute of Technology, have they solved one more problem right at this moment, will absolutely go up and take this North America Championship advancement. Same can be said about University of Kentucky, I believe. I'll need to verify the numbers, but these are the two teams from teams solving 6 problems that can affect Northwestern's chances of advancing to North America Championship. In the meantime, another University of Chicago team goes up to position number 5. The team name is Silly Billy, and they're now in between Jack Jacob Tech and Orange Blue. Orange Blue still have a few minutes to work on their next problem and get this accepted in time to pull them up within 7 problem solved group. But unfortunately, this is not something that can be done very easily. They still have to get the submission clearly. We see that Orange Blue unfortunately spent a lot of time working on different problems at this point. They have 3 problems approached. I believe they should not be working on problem B at this point, but probably problem J should move them forward. At the same time, the fact that they have 3 problems that they worked on means they probably did not have enough time to dedicate to the other problems. So yeah, a lot of interesting challenges and questions that we'll hope to see answered within the upcoming 7 minutes, or even after that during freeze time. But then we will not get a guaranteed answer at all whatsoever. Exciting times. Let's see how it goes. currently only have 1 hour remaining till the contest end. And this means that starting at this exact moment for our submission, our scoreboard is frozen. We will not receive any specific updates on whether solutions were correct or incorrect. We will have to only try to guess based on our contestants' behavior. But we are not allowed to update our scoreboard anymore. So this is exactly the way the scoreboard will look for us at the end of the contest. Let's take a closer look and try to analyze what is actually. In the first place, we currently have Team Ipatsu from University of Illinois at Urbana-Champaign. They have solved 10 problems, have 687 minutes of penalty time. Second place is safely with the team Look for the Backup from Vanderbilt University. They have 8 problems solved with 473 penalty minutes, a pretty good result for that number of problem solved. Then from third to seventh place, we have teams that solved 7 problems. This team all surprisingly represent Illinois and just 2 institutions. University of Illinois at Urbana-Champaign at 3rd and 6th position with teams Unbenchable and 8-Pack, and 3 teams from University of Chicago, Jack Jack Attack, Orange Blue, and Silly Billy. Currently, even though a few minutes ago when I was talking to you previously, I said that Orange Blue still have a few minutes to catch up and overtake their colleagues from Jack Jack Attack. Unfortunately, because they submitted problem J, and problem J they already had an incorrect attempt at, they still had to finish in 5th place after Team Jack Jack Attack. At the same time, already now, they have an attempt on problem K, which may or may not be specifically to mislead other teams, but assuming it's successful, they would move up to the 3rd or 2nd. Then we can see quite a lot of teams with 6 problems solved, starting with position 8 and finishing with position 14. These teams represent a wider variety and diversity of universities. We start with Northwestern University, then Illinois Institute of Technology, University of Illinois at Urbana-Champaign, and University of Chicago, and Vanderbilt University again, and then University of Kentucky and University of Chicago. Once again, not much variety in problems solved. I would like to specifically highlight Team AHH from University of Chicago, who actually are the only ones to solve problem B in this course, which virtually gives them a preference over the other teams with 6 problems solved. Because if they solve problem J, which we know is absolutely solvable, and every other team in top 14 actually solved it successfully by this point, they will go up to the group of 7 problems. So virtually, Team AHH actually solved 7 problems. At the same time, the same cannot be said about the team from University of Kentucky. Even though they currently have 6 problems solved and an attempt on another problem, this next problem they've been working on is unfortunately problem B. And we know that problem B is a pretty tough nut to crack. So this submission is, well, I don't want to say unlikely, but is not very likely to be correct at this point of the if you move forward, we will see another attempt on problem K from Team Orange Blue, which implies that their previous submission on problem K was unfortunately again correct. As I've already said, even though we will not have access to official verdicts of the submissions, teams still receive their feedback so they know what's going on, if their submission was correct or incorrect, if they need to continue working on that problem, or if they can actually switch problems. And then starting at position 15 and going down up to 38, we have huge number of teams who have solved 5 problems so far. And 5 problems are mostly the same set of problem A, D, G, H, and I. These problems were the easiest at the very beginning of the contest. As I've already mentioned, all of them were solved within the first 20 minutes. But currently, we see that more and more teams actually were able to dedicate enough time to figure all of them out. And up to position 38, we have these 5 problems solved by every single team on this. This lines out very nicely the list of upper half of our leaderboard, and then in the lower part, we see that teams who solved just 4 problems are mostly missing problem H, which I believe is natural, and then we have just few teams who only solved 3 problems or only solved 2 problems in the leaderboard. Interesting detail, we don't have any teams that solved just 1 problem. Well, this is probably for the best. I hope that it means that among these easier problems we have, all of them are absolutely doable. And if teams figured out this, reading and writing of contest data, they are absolutely able to then identify all the necessary steps to move on with multiple. Okay, I think now would be a nice moment to read problem H. I know thus that we missed it during the contest, but this is still one of the easier problems, and I would like you to actually know a little bit about it. Okie dokie. Problem H is called diverse content. Write what you know. The judges for a certain programming competition have end problems and are trying to prepare a contest using K of them. The judges have tagged each problem with a list of topics needed to solve that problem, not to overly punish teams not knowing a specific topic. For any given topic, at most half of the problems on the contest can have that topic. Compute the number of distinct contests the judges can prepare. 2 contests are different if there is a problem that appears in one contest but not the other. In particular, the order of the problems in the contest just doesn't matter. And we have the following input and output data. First line of input has 2 integers, n and k, number of proposed problems and number of problems that will be used in the contest, and both are relatively small. We only have 20 problems proposed in total max. Next n lines each begin with an integer t, the number of topics for that problem, and then t unique topics follow. Each topic is a string of lowercase letters, and the length of each of them is at most 10. You calculate number of distinct contests the judges can prepare. This is pretty fun. I like the write what you know intro to the problem, which somewhat leads us into the discussion of judges trying to come up with them problems, because sometimes to figure out a new problem, figuring out a new problem requires a lot of research, up-to-date algorithms, data structures I've already mentioned, reading state-of-the-art papers and problems. Whereas in the other situation, you just write a problem about something that you faced personally, and it makes it all that more exciting. In this case, we are only allowed to, for each topic, we're only allowed to have at most half of the problems with that topic. Well, this sounds pretty easy to identify. So for each of the topics, we need to pull a number of problems in there. This also sounds a little like dynamic programming, but I'm unsure based on the given constraints that this is a way to go. This is interesting. We do not care about problem order, but we still want to make sure that we're not pulling too many categories in the same contest. Oh, the fun part about sample input is that it actually demonstrates a few of the problems having multiple topics. So we need to make sure that we take as few of this as possible, as well as. Okay, let's try to figure out a very straightforward solution. In time, Vanderbilt University look for the backup, submits problem B, which is probably not the problem to work on, but they continue submitting that, as well as orange, orange, blue. Have just made another attempt on problem K. We will not know the results until the very contest end, but I would be happy to show you how the optimistic leaderboards work. And we have a submission on problem B from our leaders, so this will be an exciting part. Please pay close attention. This is not the real scoreboard. This is an optimistic scoreboard. It's optimistic in a sense that it has every single incorrect submission to each problem that was submitted during freeze time resolved as a success. So theoretically, team in first position may have 11 problems. Theoretically, team in second position can be look for the backup with 9 problems, and orange, orange, blue have they successfully solved problem K at their last attempt, could have 8 problems. Once again, this is not the official leaderboard. This is just an optimistic view to that. Just a reminder that this is how the real scoreboard looks like. We still have so many frozen submissions, and trust me, a lot more are here to come. So now the fun begins. We see that most of attempts on solving problems are on B, D, H, and J. And I absolutely understand trying to solve problem H, which is more or less mandatory for those teams lower in the leaderboard still missing problem H. But I cannot understand so many submissions on problem D. I feel like there is a lot of work to be done. We still see a little more submissions on problem J, as demonstrated by the statistics. And it's very surprising for me to see so many submissions on problem D, and well, obviously on problem B as well, but problem B is somewhat now your only choice against problem A, for example. And apparently both options are not too great for our contestants. It'll be exciting to see how the things progress, and we'll be back with you in a 40-minute contest. Well, surprisingly and not surprisingly, we see less and less reasonably paced solutions. And instead, we have more and more random submissions because contestants decide that it's not enough time to actually try and debug anything. It's just better to submit multiple in a hope that this works. One of the examples of such submissions would be submissions from Team Orange Blue on problem K, even though we're just 22 minutes and 20 seconds into the freeze time. They already made 13 submissions on problem K and counting. This may look crazy, but there is a little bit of software engineering to that as well. The reason to do that, one of the reasons that may be to optimize one of the constants. So if you're doing an iterative process and solution in your problem, you may not know the correct number of the correct parameter or whatever optimization are you using. And so probably just trying a few dozen of different versions can help you, but it's very important to do so very carefully because you still want to receive your feedback in a reasonable time. And here comes another submission from Orange, Blue, and Black. It appears to be that the same strategy is also used by Northwestern University on problem D. The difference between, well, both of these teams are actually submitting that actively because this exactly means their advancement to North America Championship. Orange, Blue, if they're able to get this one extra problem on top of Jack Attack, they will steal that spot. But for Bite Me from Northwestern University, as I mentioned, there are so many teams from this 6 problem solved range that can actually just go absolutely over them and steal their place. So it just makes sense for them to try as hard as possible. And whereas problem K looks very complicated and has just 2 successful solutions as opposed to 1 successful solution of problem B. Problem D looks like something Bite Me will actually be able to not just bite, but also chew. We'll absolutely be following them in this process. It's always very curious how all the different verdicts actually change one into another, because as we saw that for Ipatsu with problem B, they had 4 incorrect submissions before the freeze time, and the submissions were different in their verdicts. Some of them were time limited, some of them were wrong answers, and sometimes you just optimize these tiny little details to try and fit another approach, to try and probably work around another corner case or something like this. And at this point of the contest, your main limiting factor is not your computer time anymore, but then your physical clock time. You're running out of the 5 hours of the contest, so you may not have enough time to properly reread your solution to make sure that you find a mistake in there, but instead just trying multiple options here. And another significant advancement is that team from team unbingeable from Illinois University of Urbana-Champaign just submitted a problem case. So this is an interesting scale. This is something that we have not yet seen. Uh, Once again, if you will see another submission from the same team on the same problem, it is not guaranteed, but is very likely that this team have not solved this problem yet. So in optimistic scoreboard, we are actually accounting for these changes so that we are able to match real penalty time as close as possible. Well, but penalty wise, there is really not much that can be done. Total duration of the contest at 300 minutes, which means that at this point, every team that solves the problem right about now will cost them 270 minutes, which is a lot, but also very easy to add to given values. If you look at Team Unbenchable, even if they solve their extra problem, they will still be behind. Look for the backup. because if we add 244 to 270, we'll get over 500 penalty minutes, and look for backup has just 473. The same goes for Jack attack, and as we mentioned, if orange blue solves this problem right away, they have just 7 minutes of penalty time difference on this point, and the only thing that matters apparently is the number of problems solved. We don't see too many interesting freeze time submissions. We see a lot of struggle with problem K. Surprisingly, we see some of the submissions on problem K from teams from lower part of the leaderboard, say from place number 9. On the other hand, problem J and problem H are definitely on the menu tonight, and we see submissions into J from all the different teams. For example, right now, 2 University of Chicago teams are trying to do that simultaneously. Let's try and consider what would an optimistic scoreboard look like. Here we go. This is not the real scoreboard. I will not be tired of repeating that. But theoretically, Ipatsu can be in first place with 11 problems solved. Then team from Vanderbilt University in the second place with 9 problems solved. Unbingeable finally can theoretically have 8 problems solved, but Jack Attack can be the team that stays in place from the current top of leader. Orange blue theoretically can be higher, but then 19 incorrect submissions. This does not look good. And we have a few more teams that have not submitted anything yet after the freeze time, being APAC and Silly and a few submissions into problems D and B for Bite Me, IATA, and CP Joyers. And then we go into a few that again have not submitted anything just yet. Optimistically, if we count all the teams that are currently in the scoreboard, we will still have 80 teams solving at least one problem. Oh, in case of this competition, at least 2 problems, because we still do not have a single team who have solved just one problem. But there is one team that can do that. We're rooting for Team TTU3 from Tennessee University. They're currently at 6 incorrect submissions on problem C, which is heartbreaking. And I hope that they have enough time to finish that problem. Unfortunately, they don't have another attempts on any of the other easier problems, so I assume that they have not really been watching too closely at the leaderboard or following all the kinds of options through the leaderboard as well. But we'll be able to figure that out in a few minutes. If it actually the case, they are at -8 in our leaderboard currently. Problem C is definitely a doable problem, so let's hope that whatever bug they have is just a small typo. And coming back to normal scoreboard, as we just have 30 minutes till the competition. have an exciting update. Well, apart from 1,000 more submissions into problem H from Team Orange Blue Blue, we now have 2 submissions from Unbenchable, one into problem K and one into problem L. This is very exciting. This gives them a lot of interesting chances and opportunities, and theoretically they may be up in 9th problems group, and team look for the backup continued submitting problem B, so we're unclear if problem B is actually solved or is still a work in progress. Most of the teams with double digits in their place are currently submitting problem J, which is, I repeat, a good idea. I think that is exactly what they should be doing. And even even though most of the submissions are like one-off, I would like to also highlight that Bite Me have now 13 incorrect submissions on problem D. Well, we don't know if they're incorrect, but we know that there's been 13 submissions after the freeze time, which is quite a lot for just 38 minutes if you think about it. So yeah, looking forward to more advancement in this direction. Every time that you see a larger submission number, it looks not great for the team. So let's hope that we'll see as few of these as possible. minutes till the end of the contest. And it's not just a few more submissions on K for orange, orange, blue. It's not just a few more submissions on problem L, unfortunately unbingeable. It's also a surprisingly quiet activity from our leaders in Team Katsu. After their first submission on problem B, they have not actually else on problem B. So this may very well mean that they've actually finished this problem and are now, well, probably just chilling, but also with the only one problem left. This sounds like probably an attempt from one of judges. Christian was indeed correct, and his idea of this team ending with all but one problems may turn out to be right as I'm talking that another submission from unbenchable with problem L, which all is not great and which usually means that unfortunately not moving towards the correct submission, or at least the previous submissions were indeed incorrect. Just 14 more minutes every submission that will be accepted exactly at this moment will add submitting team 183 minutes, I believe. So if you would like to calculate the penalty time roughly, that will help you a lot. Another submission L from third place. So well, this is probably just a little too many. Let's go back to Optimus to see how it works in our case. So theoretically, this is the leaderboard that we. This leaderboard takes into account the fact that if there are multiple submissions problems during, then we are only treating as accepted the last one. Oh, and we have a submission from Jack Jack Attack. This is they just submitted problem K. This is their first submission in freeze time, so they had enough to work on it. Exactly 47 minutes, and they instantly submit again. Well, then it suddenly stops looking that promising right away. Well, let's hope that this is yet another one of those solutions that just need a few tweaks in parameters department to become a correct one. Will Jack Jack Attack be able to defend their position of best team University of Chicago, or will Orange Orange Blue finally figure out problem K and go up with 7 problems solved? Well, we'll learn that in just a little over 10 minutes. under 5 minutes till the contest. And you know what? Jack Attacks just submitted a whole bunch of submissions into problem K. They're currently at 12 submissions after the freeze time. Orange Blue are at 25 submissions after freeze. Unbingeable at 6 submissions on problem L and 2 submissions on problem K. And our current leaders, Team Ipatsu, with 10 problems. And mind you, there is no other team that is even remotely close to 10 problems, but they are indeed the proven leader at this point. They have stayed with this one submission in problem B after the freeze time and absolutely nothing else. So it's just very possible that they will stay in the first place even before we look at the final scoreboard at the closing ceremony. So this is entertaining. At the same time, we are getting a submission from Orange Blue on problem E, and this is something new. They have not had any attempts at problem E beforehand. Even more, I would say that barely anyone tried problem throughout the whole contest. We have one successful submission from our leaders from University of Illinois at Urbana-Champaign, and we have a one-off submission from the University of Kentucky in 63rd place with 3 problems solved and then a couple of attempts to solve problems after the freeze time. So this is a very interesting detail. In the meantime, in 3rd, 4th, and 5th place are just frantically submitting their Ks and Ls. Unfortunately, as this is a non-stopping flow of the same attempts into the same problems, it's pretty unlikely at this point that one of these a long time ago was a success. But still, even getting a problem correct after 28 penalties is something that can bring team up to the lead and actually decide advancement to North America Championship. At this point, penalty time is much less important than the number of problems solved. This is the evolution of the contest. We are now under 2 minutes, so just 120 seconds until we'll finalize the result. Obviously, it doesn't matter if contestant solution will be able to finally pass through or pass all tests before the contest ends. It's just important to be able to submit this correct solution before the contest ends. Judging system, contest control system will make sure that each timely submitted solution will be carefully judged against all the same test cases that all the other solutions work through. At the very beginning of the contest, I was very surprised that we had so many um, so many correct submissions, such a small percentage of incorrect submissions. And it still stayed true for problems A, C, G, and I, even though problem A fortunately turned out to be less popular with our contestants. It just reads a little more complicated, whereas judges expected it to be somewhere in the 70s on the number of solves. It's still a great result in just 4 submissions that are tentative in total, or just 2 are for sure incorrect, which is a great number, and looks like the problem was actually very well received by our contestants. We have literally 0 pending or incorrect attempts at problem G, which is incredibly impressive. And then 4 more pendings at problem C, 3 more not yet corrects on problem I. So many attempts on problem J, though, and on problem B, problem L. This is exactly the thing that we currently see in the testing queue to your right. And now the contest is over. It will take a little for the contest to be finalized, and absolutely stay tuned with us to follow the closing ceremony and a reel of the final results that will hopefully take place in about 30 minutes. See you all very soon and stay tuned.
say welcome to everybody to the closing ceremony for the Mid-Central Regionals for the 2023-2024 ICPC year, or academic year, really. And in a few minutes here, I'll be showing the final results. There were a few minor glitches in the problem set early in the contest, but those got ironed out and everything seemed to go smoothly. We didn't seem to have any real problems with the contest itself, so the results should be pretty clear. Nothing is official until the end of the time for appeals and whatever, but we should be good to go shortly. And again, I would like to thank our sponsors, and our main sponsor for the regional is JetBrains, and they have sent us a video to show a little bit of what they do. And let me go ahead and play that video to give our sponsors their due. We really appreciate all they do for us. And so here's a little bit on JetBrains. Well, thanks again to JetBrains for sponsoring the regionals and for helping us sponsor the contest all over the world, as far as I know. And we really appreciate all of the sponsors and all of the other folks who help out with the contest. I'm not going to try to name everybody. I'm sure everybody wants to get to the results as soon as possible, but let me make sure I say thank you to all of the site directors, especially those of you who ran sites where you took in teams from other schools. But in addition to that, the folks who ran sites for just their own school, the microsite folks, it's great to have that option, and it still takes time to get that done. And certainly thanks to all the coaches. Without the coaches, we don't have teams and we don't have a contest. Sometimes the team members think that they sort of spring out of nowhere, and I guess in some places they do, but in many places it's the coach that spends lots and lots of time and gets very little benefit for it. And we really appreciate the coaches and all the work they do, and all kinds of other folks. I guess a quick little shout out to the Caddis folks, Frederick Niemela and Greg Hammerly in particular. We had half a dozen team changes at the last minute. And okay, I can make changes to the ICPC system and say that those students are on those teams. But without Caddis credentials, they're not really on those teams. And the Caddis folks, with 5 regionals being run at the same time, were able to get all those changes made for us. So that was pretty impressive. And I noticed that Lydia, sure, I don't really know how to pronounce her last name. Sorry, Lydia Perovskaya. Hopefully I came close. She ran an ICPC live session for us. I'll hopefully get the link to the saved version of that. A great discussion of the problems with Christian and some others talking about how to solve problems and just contest in general. And I got on for a little while and talked about our contest for a little, but I think that's enough of the trying to say thank you to everybody who was helpful here. Partly trying to give people time to jump in if they wanted to, but let me go ahead and see if I can get the resolver to run. And let's see, this is going to be a little bit quirky. Yes, and most of you have seen the resolver before, but it's a really nifty piece of software that displays the results from the end of competition here. And see if I can do a share screen of the resolver window. Okay, that's not really the window I wanted to share. Sorry about that. See, try that again. Sharing the executable doesn't help a whole lot. Oh, so it wasn't on my list of sharing. And now my screen is blank. There we go. And once again, I have no easy way of knowing if that's actually working. Sorry about this. I have a slightly different graph than what I just did. Okay. It should be good to go. Okay, and as it shows the concept and implementation by the folks who developed the resolver system here, and let's go ahead and see if this is going to work for me. It worked a little while ago. This is a list of all of the teams that we have, and the green little boxes with numbers are problems that were solved correctly before the scoreboard froze. The reds are problems that were solved or that were not solved. They're incorrect submissions. And the yellow, gold, whatever color it shows up on your monitor are problems that were submitted during the time that the scoreboard was frozen. So down at 81, we have teams that did not solve any problems. Hopefully they had fun trying, but sometimes that happens. Shoot Palm Moy from Illinois Wesleyan, UCA Bears from Central Arkansas, TTU3 from Tennessee Tech, to be deleted. Not sure if I was supposed to delete that team or whether they just thought that was a funny name. From Tennessee Martin, Shield from Truman State, MSU Bears from Missouri State, Harding Translucent from Harding. Still searching for a name, great name for a team, but they do not have any pending runs. So we'll go on to Tricode Titans that have 2 pending runs. The first one was problem A, their 6th try at 270 minutes, and changed to green, so they got it right, and they move up to 71st place. So we're back down to spot 79 with the Gorlock Blues from Webster. They have problem K submission at 286, and that did not work, so they stay in 79. UTM Team 1 from Tennessee Martin does not have anything pending. Plum from Purdue University Northwest does not have any pending runs. TTU2 from Tennessee Tech does not have any pending runs. UTM Team 3 from Tennessee Martin does not have any pending runs. If I horribly mispronounce your team name or school name, send me an email at some point, and hopefully I won't do it again next year. Lion Bites from University of Arkansas Fort Smith has a pending run for problem H, and it did not work, so they stay in 74. Lindenwood has 3 pending runs, one for problem A, and that worked, and they move up a few. SLU White from St. Louis University has a pending run for, let's say, problem I, and it did not work. They stayed in 73rd. Tricode Titans from Northwest Missouri State had a pending run that did not work either. UAF2 from University of Arkansas has nothing pending. They stay there. Lindenwood still has 2 pending runs, one at 296, and that worked. Usually when you see a 296, that's a Hail Mary and it doesn't work, but that did work. They move up some.
Given the balance.
Maroon from Eastern Kentucky has the pending run and it did not work, so they're in 70th.
But you have to check
It Happens from Maryville has nothing pending. Team ZDJ from Bradley has nothing pending. Evansville Orange from University of Evansville, 1 pending run, but it did not work. IUS2 from Indiana University Southeast has nothing pending. NKU Team 1 from Northern Kentucky has nothing pending. UKY Tryouts from University of Kentucky has 2 pending runs, one at 290, and that does not work. One at 257, that does not work, and they're still in 64th. OBU from Wachita Baptist has nothing pending. Lindenwood still has 1 pending, and it did not work. There in 62nd. Golden Gorlocks has from Webster has a pending run at 299 and another at 272. That one works. They're moving up to, didn't quite see that. It looked like 39th, moved up pretty far. Murray State Racers Gold has nothing pending. Batman from Northwest Missouri State has nothing pending. TTU1 from Tennessee Tech has a pending run, and it did not work. Red Hawk 1 from Southeast Missouri State, pending run there, and another one there. They both failed, so they stayed in 58. UAF 4 from Arkansas has a correct run. They're moving all the way up to 38th, I think I saw. Untitled Lipscomb has a pending run, and that did not work. Lipscomb Bisons has nothing pending. IUS 1 from Indiana University Southeast has 1 pending run, and it failed. UAF 3 from Arkansas has nothing pending. UKY Blue from University of Kentucky has a pending run, and it failed. But notice a darker green, that means they were the first to solve problem I. And congratulations to that team for being first to solve in a problem. At the higher levels of the contest, they give prizes for first to solve. Unfortunately, we're not able to do that at this point. Governors from Austin P have 2 pending runs. That one failed, and that one failed, so they stay in 52nd. 30 Bit from Bradley. Oh, that didn't work either. Red Hawk 2 from Southeast Missouri State has 1 pending run, and that failed. Mango from Purdue University Northwest, nothing pending. Bears IO from Missouri State has 1 pending run, and it did not work. Lion Bits from University of Arkansas Fort Smith has 2 pending. That one did not work, and that one did not work. They're still in 47. SLU Blue from St. Louis has 2 pending runs. That one did not work. That one did work, and they're moving up to the 30s. Apple from Purdue Northwest has a pending run, and it did not work. TM Team 210, not sure why 210, but oh well, they get to pick their name, And they have one run at 299, so not likely, but you never know. It did not work. Murray State Racers still has one pending run, and that did not work. UKY Wildcats has a pending run, and they're moving up to 36. S&T Amethyst from Missouri University of Science and Technology has two pending runs, and they did not. Golden Gorlock from Webster has nothing pending. DePaul Gold has one pending run, and it did not work. SOU Blue, nothing pending. UAF 4, nothing pending. Lion Nibble, nothing pending. Washington University in St. Louis has one pending run at 299. And as usual, 299s almost never work, but sometimes they do. Wildcats, nothing pending. SBU Purple from Southwest Baptist has a 299 pending run, and it doesn't work. S&T Ruby, one pending run, nope. Meow from Northwestern, two pending runs. That one did not work. That one did not work. Wow. A whole lot of things that didn't work in the last hour. Starting Black, that did not work. Arkansas UAF 1, nope. Lipscomb Gold, no, and another no. UAF 5, nothing pending. Live Love Leak Code from Vanderbilt, two pending runs. That one did not work. That one did not. S&P Silver, nothing pending. Coding is Fun, another great name for a team. Two pending runs. That one did not work. The 23rd try for 298 gets the persistence award, perhaps, or one of the persistence awards, but it did not work. I've always thought it would be kind of amusing to give an award for the most tries that actually got something to work, but then teams would perhaps start submitting things that didn't work on purpose, and that's not a good plan. But anyway, Team Snafu from Vanderbilt has a pending run, but it did not work. KPTCICPC from University of Chicago, that 299 did not work. Herding Gold, nothing pending. Three of a Perfect Pair from Chicago did not work. Hendrix Warriors from Hendrix College, that did not work, and that did not work. UIUCC, University of Illinois at Urbana-Champaign, has a bunch of teams in the top 20 here. Yep, that one puts them up to 15, at least temporarily. Washington University Team 1 has two pending runs. That one did not work, and that one did not work. Evansville Purple has a pending run and did not work. Illinois E, two pending runs. That one did not work. That one did not work. S&T Gold has three pending. Nope. 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 They stay in 17th. Still not bad. University of Louisville Cardinals in 16th. Two pending runs, and they stay in 16th. Illinois C is in 15th. Hide and Seek from University of Chicago has two pending runs, and that one works, and they're up to 8th place. Kentucky Algorithmics, two pending runs. That one did not work, and that one did not work. Vanderbilt in 13th has nothing pending. From University of Chicago, nothing pending. They do have first to solve on problem B. And also, we're giving medals, and I will actually get medals in. I've ordered the medals, and they will arrive shortly, I hope. And I will be sending those out in a week or so. And the top 12 teams, 4 teams get gold medals, 4 teams get silver medals, and 4 teams get bronze medals, somewhat akin to what happens at the higher levels of the contest. So in spot 11, University of Illinois CP Enjoyers, they have one pending run. They move up to 8th. Illinois Institute of Technology in 11th, they have 2 pending runs. No, they stay in 11th. And that means they're a bronze medalist. Bite Me from Northwestern. I'm glad they spelled it with a Y. Again, a little bit of persistence here. Their 13th try at 277, and it didn't work. But given that they're in 10th place, that also means they're a bronze medalist. hide and seek from the University of Chicago, nothing pending at this point, but again, they're bronze medalists. And they will actually be getting medals, not that we're announcing that they're a medalist, but that doesn't mean anything. And these guys, they're in 8th, so they're a silver medalist. Silly Billy from the University of Chicago has a 299 pending run, and that failed. But again, they're a silver medalist. Ape Pack from Illinois, nothing pending, but they're in 6th place, so they're a silver medalist. Orange Blue from the University of Chicago, 4 pending runs. Oh, that could move them up significantly. This one's a 299. Nope. 296. Nope. 281 on the 27th try. Nope. And 296. Nope. 5th place, and that means silver medal. Jack Attack, where the second Jack is spelled with a Q. They have a 299, and it did not work, but they're in the top 4. So that means they're a gold medalist. Unbingeable from Illinois has 2 pending runs. That one did not work, and that one's a 299, and so not likely, but we always check to make sure. But they're still a gold medalist. Sorry about that. It's hard to turn off all the phones in the area. In 2nd place, and not a whole lot of suspense here because they have just 1 pending run. They can't get up to 1st, but oh well. Let's see what happened with their 1 pending run here. Hey, it worked. So they're up to 9. They are clearly in 2nd place. And we're up to, again, a gold medalist. And I guess I have forgotten to mention a few of the first to solve. They were the first to solve on problem G, and Orange Blue first to solve on C and D. And then finally, our champions, did they get 11 or 10? 5th run at 250, and it worked. So they did get 11. Nobody, I think, ever submitted problem F. But there's our champion, Ipatsu. Again, if I horribly mispronounce your team name and you plan to use it again next year, please let me know. Gold medalist, first to solve problems A, E, H, J, K, and L. And they solved 11 problems, and they are our champion. The other thing I should look at before we close down the resolver is the top 4 schools, not the top 4 teams. The top 4 schools are guaranteed places at the North America Championship, which is scheduled to be in Orlando at the end of May. And below that is possible. There are a modest number of wild cards, but it's something like 6 wild cards for 11 regions or something. So it's unlikely, but it could happen if you're not one of the top 4. But anyway, the top 4 schools would be Ipatsu from the University of Illinois. Look for the backup from Vanderbilt. Jack Attack from the University of Chicago. It's 3 schools. Looking down, the next school is, looks like Northwestern. Bite me, Northwestern at spot 10. Illinois, Vanderbilt, Chicago, and Northwestern. As far as I can see, are the top 4 schools. Again, none of this is official yet, but I don't know of any problems we had. And IIT, just below Northwestern, there's some chance they could get a wild card bid, but there are not as many wild cards as there are regions. So I would not be making reservations to go anywhere if I'm not in the top 4. And again, these are unofficial. So even if I were in the top 4, I wouldn't be making plain reservations. I've heard the teams have done that and lost something when it turned out that there was a glitch in the system. So, But congratulations to all these teams that did well. We had a whole lot of teams solving a whole lot of problems. And anybody who's on this first page is a medalist and deserves great congratulations. And there are a whole lot of other teams that did very well. The ICPC live broadcast that Lydia did had some discussion of how to do some of these problems. And we should be posting solutions after a while. Once I get the okay from the judges who created the solutions and all that, we will be posting the sample and well, the testing input and judges output and the judges solutions, and hopefully discussions on how to get to those solutions, not just code, where sometimes looking at code can be more than a little difficult. Okay. And screen sharing stop. And that's effectively all I know that I need to do. I guess that's the end of the closing ceremony. So thank you all for attending the closing ceremony, and I'll go ahead and stop the recording and then stop the closing ceremony.
Recording stopped.
Hopefully we'll see you all next year.